Dimming the lights also helps prevent reflections from inside Orion onto the windows. Ahead of this lunar flyby, let's dive in and explain what you can expect over the next several hours. The crew has about 6 hours allotted to make observations about the moon. Throughout the flyby, their activities have been precisely timelined. There are five blocks of time during which the crew will be observing the moon from Orion's windows. At any time, 2 members will be at the windows working in a pair. One crew member will be taking photos from window 2 with a blue shroud over the window. This can help prevent that glare or reflection from inside Orion. They have an 80 to 400 millimeter zoom lens to use. The other astronaut will be in window 3 using their portable computing device, you'll hear that referred to as PCD, to make annotations. Both of these crew members will make audio recordings of what they are seeing, and they'll wear headsets connected to those PCDs. Those audio recordings will be sent to the science team at a later date. We will not hear them live. The 2 crew members at the windows will swap roles and positions halfway through their timelined block. The other 2 crew members who won't be at the windows at that time will be serving in the background as support. One will be conducting the science sit reps, or situation reports. This is what we will hear live from the crew. They'll be calling down a few times each hour to discuss what they are observing. Those situation reports include how the crew is positioned, any missed targets, or anything unexpected they saw, lunar target descriptions, any hardware issues, and of course, their emotions and reactions as they fly by the moon. The other support crew member will take pictures of the astronauts at the windows and serve as camera support, providing new SD cards when needed. There's a 15-minute time frame between each observation block during which the 2 support members switch places with the crew making observations. Two views, both coming from Orion. There on the left, the inside of the spacecraft, and on the right, a view of our moon, the destination for today. During the lunar flyby today, Orion will provide astronauts with a full disk view of the lunar surface. They'll have a higher vantage point, much farther than Apollo's lunar orbits on average. And these astronauts can observe both holes and large-scale geologic features in a single view. And due to our April 1st launch date and current illumination conditions, the Artemis II astronauts have become the first humans to directly observe certain far-side regions of the moon with unaided eyes.
How do I, is it all?
We are now 36 minutes until we see the Integrity crew pass the Apollo 13 distance record. And joining me on console, I have Julian Gross, the Artemis curation lead. Thanks for joining me today.
Thanks for having me. I'm very excited to be here.
We're very excited to have you. So can you tell me about your role as Artemis curation lead and what that entails?
Yeah, so for the overall Artemis campaign, I'm the Artemis lunar sample curation lead. That means I'm helping NASA to return the next set of lunar samples from the lunar surface. And for Artemis II specifically, I'm one of the science theme leads, and specifically I'm responsible, or the voice, for impacts, poles, and landing sites.
Fascinating. So what helped us select the targets that the crew is going to be photographing today?
So we had a plan coming in where we basically made a list of all the available targets during the April launch window, because before you launch, we wouldn't exactly be sure which targets would be visible. And so once we launched, we then were able to cut down on that list and prioritize our targets. And the 5 theme leads came together and really discussed and talked through which which targets we could then see and prioritize. And so that made it into our plan. We worked then with timeline to make sure that all the targets are visible. Some targets are time dependent, like Earth-set or Earth-rise, and some targets will rotate out of view when Integrity starts going around the moon. And so we put these in early so that the crew has a chance to describe those to us.
Fascinating. I cannot wait to hear what they have to say. So we just heard them say that their long lens is configured. That's very exciting. And for us, when we look at the moon from Earth, what features are we seeing that the crew will also fly by today?
Yeah, so I really hope that people on Earth who are in nighttime will look up into the moon tonight. The features that the crew will see that we can also currently see is Aristarchus Plateau. Grimaldi is another feature. They're going to be sort of on our limb. And then Oceanus Procellarum, that really dark, large area on the near side that we can see. The crew is going to see that in the beginning. The more they fly around, the less of that they will see. So those are targets we will hear them describe early on in the flyby.
Fascinating. Well, and the crew has been training for years for this day. And so we're going to hear them make a lot of calls about what they are seeing on the moon. And they're going to use a lot of interesting terms that I myself need some brushing up on. So could you walk us through a few of the things that we'll hear them use to describe the moon, like albedo, exosphere, ejecta, just some of those major terms we expect to hear from the crew?
Yeah, of course. Albedo is basically a term of a reflectiveness of the surface. And so high albedo usually for the moon means bright areas, and low albedo means like darker areas. And so when you look into the night sky, you can see the high albedo areas are the white parts and the low albedo ones are the darker areas. Ejecta is when you have an impact and it ejects or throws out material that then ends up on the surface, and you can see that as sort of rays or ray systems. So you might hear them describe, oh, I can see Om, for example, with its rays. It has an isometric rays coming out, and so we're excited to hear them describe that. You might hopefully hear stuff about color or color hues, and so if they can see any changes in those color hues from like white to gray to maybe brownish, we're excited to hear about that. Exosphere is the almost no existing atmosphere of the moon. It's barely there. But there is dust on the lunar surface that can get lofted up through electrostatic forces. And when the sun goes behind the moon, it can scatter forward on those dust particles and sort of like create a little glow on the horizon. And so we're really excited to see if the crew can actually see that.
This is so exciting. Thank you so much for walking through all of that with us. Julian Gross, Artemis Curation Lead, we really appreciate you joining us here today, and good luck to your team.
Thank you. I'm really excited to be here.
We are now MET 4 days, 18 hours, and 49 minutes into the flight of Orion. This view of the moon from the Orion spacecraft as we get closer and closer. We're live here in Artemis Mission Control at Johnson Space Center in Houston, Texas, just about 32 minutes away until the crew surpasses the record set by Apollo 13 as the farthest astronauts to ever leave Earth. This view coming from a camera mounted on the tip of one of Orion's 4 solar arrays. Each array has a camera on its tip, and so we anticipate getting views throughout the lunar flyby. Of course, except during the point of loss of signal when the spacecraft flies behind the moon. Inside the cabin, the crew are configuring the inside of Orion for today's flyby, making sure they have everything just where they want it to help them take the pictures that they are aiming for the science team here on the ground. Coming up in just a few minutes, we will have a pre-lunar flyby conference. During that Lunar Flyby Science Crew Conference, our science officer here on console, Kelsey Young, will be speaking directly with the crew members about their targets, about their goals for today, what they expect to see, and what we are hoping to hear from them. We have a lot of milestones coming up today, so make sure you don't miss them. The first coming up, again, at 1:56 p.m. Eastern Time, the crew will pass the distance from Earth record set by Apollo 13 in 1970. At 2:45 p.m., lunar flyby officially begins. The crew will have that time on their schedules to begin photographing and providing audio recordings of what they are seeing on the moon. At 7:02 p.m., Orion will make its closest approach to the moon, approximately 4,070 miles away. Of course, all of these numbers are going to have to be confirmed following the flyby. These are estimates, and we are working with orbital mechanics. At 7:07 p.m., Orion reaches its maximum distance from Earth, approximately 252,760 miles away from us all. At 8:35 p.m., the spacecraft will enter a solar eclipse. The crew will become the first to see a solar eclipse from the moon. Ahead of the official beginning of flyby today, Kelsey Young, Artemis Science Flight Operations Lead, will be conducting a pre-lunar flyby crew conference. She will give information on camera setup, remind the crew of their intended targets, answer questions from the astronauts, and more. Young will help the crew set their targeting timeline, which counts down the time they have to image each target and what they'll be capturing next. She'll also remind them that the ground team will be calling for science sit reps, also known as situation reports. Those are essentially call-downs to report what they've been observing. They'll continue to do this even through their LOS, their loss of signal, as those communications will come down later on after they reconnect with us on Earth. This view in the cabin, you can see the crew members are already using their cameras, getting set up, and they have dimmed the cabin lights to allow them better visibility outside of the windows and fewer reflections. Now, 28 minutes until they become the humans to travel farthest from our planet.
Houston Integrity, we are ready for the conference on your call.
Houston is ready for the conference, passing you over to Science. Good morning, crew. This is Science. We couldn't be more excited for a full day of lunar and planetary observations today, the first one in over 54 years. How do you hear me?
We hear you loud and clear, and Kelsey, you just got to know you're pulling us away from the moon right now, so let's go.
Message received. I will keep it tight here. I did just want to start with a thank you on behalf of the Lunar Science team and the entire lunar and planetary science community, of which you are absolutely a part, for what you've already done in this mission and what you're going to do today to inspire the next generation of scientists. I have to say Moonjoy is the new term that's already become our team's new motto, so thanks for that. In this conference, we'll cover hardware and config reminders, and then I'll just briefly, as you said, cover today's science plan. I'm assuming you already have your LTPs up. Confirm that, and I'll jump quickly into the cabin config reminders.
Okay, we have the LTP up just to give you a sit rep on board. You've got Reed and Christina on one PCD, and Ike has his own, and Jeremy has his own.
Copy that. That was going to be one of my questions for you, and I'll ask a question back. Is that the config that you and Christina plan to carry throughout the day for PCD use?
Negative, Kelsey. Our plan for PCD use is we have run the power cables to Windows 2 and 3, and we are going to leave one PCD. The yellow PCD will be in window 2, and the green PCD will be in window 3, and we will do that the whole day. And then the red PCD will be a rover.
Understood. Super helpful. Recommend when you guys switch in and out of PCDs to add your initials to your OneNote annotations, just so we can keep track of whose is who. And then given that you have 3 PCDs instead of 4, for the data transfer at the end of the day, recommend making a new subdirectory entitled For Science for your own photos, or with your initials, that we can keep track of which pictures came from which flashcards.
This view.
So, Kelsey, I just want to here's what we're doing. We have community cards in all cameras on board, and then when each astronaut approaches their camera, the intent is they will put their card into that camera for photos and then put the community card back in at the end of the session. But just know it is harder to manage cards than we thought, and we don't want to miss science, so it might end up a bit more disorganized.
Understood. Thanks for that essay. Just read the flashcard numbers down when you get a chance, and we'll follow your lead on the best thing to do operationally during the flyby. With that, I'll move on to windows. So the window characterization DFTO you guys did a few days ago confirmed that window 2 is ideal for imaging, so no change to config of photographer in window 2, observer in window 3, and science at reps in window 1. Coming up on a handover. Be back.
Hang on, Kelsey. The way we have it configured, tell us if this is going to be wrong. Window 2 is the long lens with a shroud.
As you heard, science officer called to the crew. We are now in a handover time period. We will regain communications with the crew very shortly. These are tracked, and we are currently on the Deep Space Network. This is the first time humans have used the Deep Space Network in over 50 years, given that we currently use the tracking data relay satellite systems for the International Space Station. This view from Artemis Mission Control on the right is Kelsey Young. That's who you hear speaking with the crew. Young is the Artemis Science Flight Operations Lead, and we also look forward to speaking with her here today. Again, we are just about 22 minutes until we reach the Apollo record. We are in a handover of satellites with the crew aboard Orion.
The T-shirt shroud for the Z9 and solar, and then window 3 will be for visual observations, and window 4 is for floater.
And thanks, Integrity, for that. Reed, we had a handover during that time, so I'm going to have to ask you to give that read back on window orientation for the crew again.
Okay, we are happy to change it, but the way we have it configured right now is window 1 has a T-shirt shroud for the Z9 for solar. Window 2 has the shroud for the long lens for both lunar and solar. Window 3 is for visual observations. Window 4 is for floater. And then the docking hatch window has had a great view, so we've done a lot of mapping through that as well.
All right, copy all, Reed. A note just on the window 1 T-shirt shroud that you can remove that for the lunar observation block if you want that extra view for another floater, but defer to you guys on that. You are go to use the full 400 millimeter zoom on the long lens, but where possible, try to keep the end of the lens flush with the window to prevent imaging through the multiple window panes at an angle. And if you have to take an image at an angle, recommend you limit the max focal length to 200 millimeters or simply acquire the images at multiple focal lengths. Last imaging update as a result of the DFTO is that if you can take the images out of the left side of window 2 where possible, that is the best half the window. Understand that might not be possible with the shroud. Any other imaging questions from you?
Okay, copy that.
Okay, last couple reminders. Don't forget the ability to take the WAV files to tag imagery that you are wanting to follow up on using the FN3 button on your camera. And then a couple quick notes on your LTP. We have refined your precise flyby timing since generating the LTP. Optimus has the correct timing for the LOS and AOS, but the LTP identifiers for LOS and AOS are roughly 2 minutes later than they will be in reality. Final LTP timing update is that the green line on your LTP should start automatically 45 minutes before the flyby. If it doesn't appear, let me know and I'll have troubleshooting steps for you. Last updates are on the eclipse, so only for that last hour today. Of course, remember if the sun is in view to use your eclipse glasses. And reminder that we will have a few activities for you prior to the eclipse to reconfigure all 3 cameras for corona and deep sky observations. These activities, some of which will occur during the forward link LOS, so we wanted to flag it for you now. Any questions before I cover the last 2 reminders?
No, we have no questions on that.
Last couple eclipse reminders, the sunset period and the first roughly 23 minutes of the eclipse will fall during that forward link LOS, but we'll still have a return link, and we're still looking forward to your science sit reps and observations during that time. And I do have a reminder for you on your preferred starting config for the eclipse in terms of role responsibility. Let me know if you want me to read that up or if you guys have that in your minds already. And if no other questions on config, I'll give you a few science-focused reminders.
Give us a quick high level, but we see it in Optimus, and I think we got it squared away. But give us your quick Kelsey high level.
Okay. A couple changes from the first LTP you studied is that Glushko is the only feature that the same pair will view twice. That's Reed and Jeremy. That's why that's the only target you see that is marked as 1 of 1 and 1 of 2 and 2 of 2. So Ohm and Oriental are in there twice, but they're by different pairs, which is why you don't see them marked accordingly. A note from feedback on your observations so far over the last couple days, a reminder that if you note structure and texture as well as color and albedo, please note any correlation between the 2, and also a reminder that negative observations are still valuable science. So a lack of color or a lack of structure associated with color is also valuable. A reminder also that your observations so far indicate it will likely take some time for your eyes to adjust. We especially heard that around your terminator observations and your color observations. So reminder to know that your eye adaptation is going to kind of come in throughout your shift, and let us know when you start to see that nuance. Last reminder is around Earthset and Earthrise. When you're viewing us back here at home, you'll be looking directly at Asia, Africa, and Oceania. So I'm sure people watching from those places here on Earth will want to give you all a wave as you take their picture. Any other questions for me?
And Kelsey, hey, when you're talking window 2 left and right side, just can you say towards window 1 or towards window 3, and then we'll know that we are talking the same language?
Absolutely. So I mean that the side of window 2 closest to window 3 is preferred for imaging.
Okay, the side of window 2 closest to window 3 is preferred for recording. Stand by, we'll talk to the crew.
Again, we are in our pre-lunar flyby science conference with Kelsey Young. Kelsey Young is the Artemis Science Flight Operations Lead, speaking with the crew aboard Orion. They've been training for this moment for years, and this is their last opportunity to get some further pointers and information.
Kelsey, for the T-shirt shroud, what window does the science team think will have the best view? Is it window 1 or window 4?
The only time we're strongly recommending use of the window shroud.
The T-shirt window shroud for the eclipse viewing. Which window is primary for Z9?
Window 1.
Okay, awesome. So we have got that all set up. And just to be 100% sure, window 1 is the most port window by the food warmer. Window 2 is right in front of seat 1. Window 3 is right in front of seat 2. And window 4 is on the starboard side by the side hatch. Do you agree with all that?
We agree on the ground. Good readback.
Okay, that's awesome. Kelsey, we're going to close with happy words. It's just incredible. I wish you were up here to see all the smiling faces, to hear all these terminologies being thrown around, and we are just fired up to get started on this day. Let me pass the mic around if anybody has anything to add.
Kelsey, it's so great to hear your voice on the loops. I just want to channel everything that you guys are probably feeling right through my eyes and heart. It is awesome to see the side of the moon. You guys made us excited for this day, and we couldn't appreciate it anymore. And we are ready to hopefully deliver on all the awesome training you guys have provided.
I'll just add, Kelsey, it is blowing my mind what you can see with the naked eye on the moon right now. It's just unbelievable.
Kelsey, and to the whole Lunar Science team, all of you, all the work you put into this, we're just grateful. Can't wait to get going. And thank you for the tipper, for Carol Crater, and for Integrity. We can see them, and we've imaged them, and can even see with the naked eye. Quite impressive. Thank you so much.
Beautiful words, you guys. Thanks so much. And I got video of the science team right now, and they are all absolutely buzzing. Looking forward to today.
Okay, we're heading into the timeline. Cheers, guys.
Of the pre-lunar flyby science conference with Dr. Kelsey Young. Young has served as the Artemis Science Flight Operations Lead, getting the crew ready. And we're live in Artemis Mission Control in Houston, but we are not the only room monitoring today's flyby. As you heard Young mention, in this same building and just down the hall, a multidisciplinary lunar science team supports the Artemis II crew in real time, including experts in lunar geology, impact cratering, volcanism, polar science, imaging, and visualization. There are two integrated facilities, and the first is the SIR, which is what you have right here. That's the Science Evaluation Room. They are embedded within Mission Control to provide science input during live operations like what we see today. Additionally, and not pictured, we have the Science Mission Operations Room, a back room that processes data, evaluates imagery, and supports rapid analysis. Our science officer on console in Mission Control Houston serves as the primary interface between the science team and the flight controllers, ensuring science priorities are represented during mission execution. Again, today, that's Dr. Kelsey Young, who will be speaking with the crew during the time they're behind the moon We will be speaking with her once the crew is behind the moon and out of communication with Earth. Back inside the Orion spacecraft on your left, closest to the camera, NASA astronaut Christina Cook. To her left, NASA astronaut Reid Wiseman. To his left, Canadian Space Agency astronaut Jeremy Hansen. And all the way in the back, NASA astronaut Victor Glover, our Artemis II crew. We are now approaching 8 minutes until the crew surpasses the Apollo 13 record. Currently 12,599 miles away from the moon, 248,507 miles away from Earth. You may also hear the Orion spacecraft referred to today as Integrity. This was named by the Artemis II crew. It is
Integrity crew, we have Reid's family in the viewing gallery. You're welcome to say hello.
Well, whether you're being serious or you're kidding around, that is awesome to hear. Thanks, Jenny. And hello to Ellie and Katie. I don't know who else is there, but it's great to know that you're in mission control right now, following along. We are having a blast up here, and the view of the moon is absolutely amazing.
I'm seeing a lot of hearts come out of the viewing gallery and even more smiles. Thanks, Reid. Copy heart, copy bracelet.
that call from Capcom Jenny Gibbons, Canadian Space Agency astronaut and Artemis II backup crew member, letting Reid Wiseman know that he has family here to support him today in the Artemis Mission Control viewing room. As I was mentioning, we have the Orion spacecraft flying today. However, the Artemis crew members named their Orion spacecraft Integrity, so you will hear calls to this entire crew with the name Integrity. They say that the name Integrity embodies the foundation of trust, respect, candor, and humility across the crew and the many engineers, technicians, scientists, planners, and dreamers required for mission success. This view live from the outside of Orion as we continue. Preparing for our lunar flyby, now less than 5 minutes from surpassing the record set by Apollo 13 astronauts for the farthest humans to travel from Earth. This will not be the farthest that Integrity travels today. They will continue until they reach approximately a distance of 252,760 miles. That would be about 4,105 miles farther than Apollo 13. However, these numbers are our targets, and we will get confirmation on those numbers as soon as we possibly can and share them with you all. We've talked a little bit about what to expect from the crew, whether that's taking photos or making audio recordings. To get a little more detailed, Reed Wiseman and Jeremy Hansen will be up first to capture imagery and record audio on the portable computing devices. You hear those referred to as PCDs, while Victor and Christina serve as the support members. The crew will switch windows and roles halfway through their shift, and 1 hour and 5 minutes later, Victor Glover and Christina Cook will be the next crew members at windows 2 and 3 to take photos and make annotations, while Reed and Jeremy take on those support roles. There are 5 viewing blocks, and the crew will swap out with each one. During 2 of the blocks, the 2 support members will also be able to enjoy their midday meal. At least 3 times per block is a science sit rep. Again, situational report. This is partially an operational status, reporting back if they missed any targets or gotten any specific ones, if they have issues with their camera or any other operational items. The other part is an actual description of the moon. This task is done by one of the support team astronauts, so that's not the crew currently taking photos or making annotations, but they do have windows 1 and 4 that they can float up and provide that information from. If you watch the entirety of the flyby, you'll also notice the crew will be photographing some targets multiple times to get observations in different lighting conditions. This is due to Orion changing their location throughout the flyby. What this crew will be able to capture in a couple of hours of the same targets in different lighting would take orbiters years to do because of solar and spacecraft positioning. This crew has studied the moon extensively, and they're also familiar with what the science team calls the Big 15. These are 15 features that they've memorized, so at any time, they'll be able to see 5 of those and help orient themselves and where they are around the moon. Those targets are diverse and complex in their geologic history, and observations of them could help answer some big-picture science questions. If you've been following the mission, you can see that the configuration of the cabin is a little bit different than what it looked like on launch day. After ascent, the crew were allowed to reconfigure their spacecraft, and you can see that they've taken down seats. They have also taken away footrests. This gives them more opportunity to move about the spacecraft. Orion itself has 330 cubic feet of habitable volume. That's about the size of 2 minivans and is 60% more cubic volume than the Apollo spacecraft. We are standing by for the Integrity crew aboard Orion to surpass the Apollo 13 record.
Integrity crew. On April 15, 1970, during the Apollo 13 mission, 3 explorers set the record for the farthest distance humans have ever traveled from our home planet. At that time, over 55 years ago, Lovell, Swigert, and Hayes flew 248,655 statute miles away from Earth. Today, for all humanity, you're pushing beyond that frontier. Integrity, over to you.
Yeah, from the cabin of Integrity here as we surpass the furthest distance
distance humans have ever traveled from planet Earth. We do so in honoring the extraordinary efforts and feats of our predecessors in human space exploration. We will continue our journey even further into space before Mother Earth succeeds in pulling us back to everything that we hold dear. But we most importantly choose this moment to challenge this generation and the next to make sure this record is not long-lived.
Thank you, Integrity, and congratulations to you and the rest of the Artemis II team.
Thank you, Houston. We have a couple more things we'd like to take this moment for. Our science team helped us out with a couple of relatively fresh craters on the moon that have not been previously named, and our crew would like to propose a couple of potential names for those items or those areas. And we spent a bit of time this morning looking out the window, and we're able to see them now both with our naked eye and through the long lens, and so we feel this is a good time to send this down, and a special shout out to Kelsey for helping us with this. The first one we'd like to suggest is a named crater in honor of our great spacecraft Integrity. And so if you were to look at Orion on the far side and then draw a line straight up to Ohm on the far side, relatively in the middle is an unnamed crater, and we would like to suggest it be called Integrity in the future. And the second one, and especially meaningful for this crew, is a number of years ago we started this journey in our close-knit astronaut family, and we lost a loved one. And there's a feature in a really neat place on the moon, and it is on the near side, far side boundary. In fact, it's just on the near side of that boundary, and so at certain times of the moon's transit around Earth, we will be able to see this from Earth. And so we lost a loved one. Her name was Carol, the spouse of Reed, the mother of Katie and Ellie. And if you want to find this one, you look at Glushko, and it's just to the northwest of that, at the same latitude as Ohm, and it's a bright spot on the moon. And we would like to call it Carol, and you spell that C-A-R-R-O-L-L.
Integrity and Carol Crater, loud and clear. Thank you.
As the Artemis II crew passed the record set by Apollo 13 for the farthest humans to ever fly from Earth at 12:57 p.m. Central Time, 1:57 p.m. Eastern Time, Canadian Space Agency astronaut Jeremy Hansen shared.
We're getting ourselves all put back together now, and we are going to dim the cabin lights and prepare for our science objectives ahead. Thank you.
Sounds good. We're doing the same down here, and you're maneuvering to your observation attitude.
As we pass that Apollo 13 record of the furthest humans to ever fly from Earth at 12:57 p.m. Central Time, 1:57 p.m. Eastern Time, the Artemis II crew shared some poignant words, specifically Canadian Space Agency astronaut Jeremy Hansen. The crew also called down 2 craters not yet named that they would like to name. One, Integrity, in honor of their spacecraft, which they have named. That's near the Ohm crater. Another near Glushko, which is a bright spot, named Carol, in memory of Reed Wiseman's wife. There was a moment of silence here in Mission Control Houston. And now the team and the Artemis II crew are ready to begin their lunar flyby. We are 4 days, 19 hours, 31 minutes mission elapsed time of the flight of Artemis II, our 4 astronauts aboard Orion. Today is our lunar flyby day. The spacecraft is currently about 12,000 miles away from the moon, and you can keep up with the distance from Orion to the moon and Earth by visiting nasa.gov/trackartemis, or you can just stay with us here because we're going to be telling you throughout the day. They are currently 248,834 miles away from planet Earth. Coming up next on the crew's timeline today will be their cabin configuration portion. You heard some calls down to Science Officer Dr. Kelsey Young earlier about how they have configured the cabin so far. This is just a little bit more of timelined activity for them if they need to further do so. On flight day 3, the crew had time on their schedule allotted for configuring the spacecraft cabin for how they intended to arrange it today. Of course, they had to take down that configuration for another test yesterday of their Orion crew survival system suits. But configuring it on flight day 3 allows them the opportunity to get a chance to see what works for them now that they are in the microgravity environment. Again, the crew is about to begin their cabin configuration portion of their timeline, though they have been working that already, as well as potentially during their post-sleep period this morning. The official lunar flyby observations are slated to begin in just about 40 minutes. That's when we'll have the crew at the windows photographing the moon, as well as making calls down about what they are seeing. Again, we are live here in Artemis Mission Control for the duration of the flyby. Currently, the Orbit 1 flight control team is on console. This room is staffed 24/7 from the time before the astronauts step foot on the rocket until the time they are splashed down and are safely recovered in the Pacific Ocean on flight day 10. Again, this is Artemis Mission Control here in Houston. We are now 11,777 miles away from the moon. We did pass the Apollo 13 record of farthest humans away from Earth at 12:57 p.m. Central Time, 1:57 p.m. Eastern Time. That distance, 248,655 statute miles from the Earth, continuing to be exceeded by the crew. They will reach their farthest distance from the Earth around 6:07 p.m. Central Time. At that time, they will be in an LOS, or a loss of signal, with us on Earth, as they'll be flying behind the moon. As the crew gets into their cabin configuration preparations, we are joined by Dr. Sarah Noble, the Artemis Lunar Science Lead. Thanks for joining us here today.
Yeah, it's quite a day.
Yeah, we are very excited. I can only imagine how you guys are doing over there. So tell me a little bit about yourself and what your role is for Artemis II.
Sure. So I'm the Artemis Lunar Science Lead, so over the entire campaign, and my job is basically to make sure that as we have this big adventure back to the moon, we actually learn new things about the moon.
Fascinating. So why is the moon such an important destination today?
Yeah, so the moon is a pretty amazing place. It is a great place to learn about basic fundamental processes that happen on like all the planets, like cratering and volcanology. And also it is, part of our Earth-Moon system. And, the Earth recycles its rocks pretty well, right, through plate tectonics and weathering and whatever. Most of the rocks on the Earth are geologically young. But on the moon, we have the entire record that goes back 4.5 billion years since we formed. And so if we really want to learn about what was happening in that period, like the moon is really the only place we can go.
We're also thinking about going back to the moon, and we want to go to the lunar South Pole. So what makes that such an interesting destination?
Yeah, the South Pole is cool, right? It's far away from the places we went during Apollo. It's different kinds of rocks there, some of the oldest rocks on the moon. It's also a place where we think there might be resources like water. There are craters that really never can see the sun because of the low sun angles there, and they get very cold. And we think that water and other things can build up in those craters, and so we're very interested to see what that might do for us.
I'm very interested as well. So for some of our viewers who might be new to this, what does lunar science look like during an Artemis mission?
Yeah, it's pretty exciting for us as we have sort of built this from scratch to try to understand how we can best use the crew to support our science. And so, we've developed a system. We've got a team in place. We've got a back room here in this building called the SIR, the Science Evaluation Room. And there's in fact a back room to that back room over in another building here at Johnson Space Center where we've got our teams of scientists working really hard. They're actually speaking to this room through our science officer. This is now the first time we've ever had a science officer in flight control room. So we're pretty excited about that. So we have a really voice out and up to the crew.
I know, it's been so exciting to hear Dr. Kelsey Young speaking directly with the crew today, now so close to the moon. And we have a live view here of the science operation, or the science evaluation room. So this is where the majority of your team is today. Is that right?
Yeah, that's right. This is a big chunk of our scientists. You can see them in there now working hard, trying to get ready for the day. And then again, there's a second room where we have a lot of our data folks, where the data will first come down and they'll sort of sift through the data and get it ready for this team to take.
What's the mood like right now in the SIR?
It is, I would say, giddy. I think we've worked very hard for this. They have done simulation after simulation. They have worked really hard over the last couple of years to get ready for this moment, and I think everybody's just really excited to see. Even already we've had some descriptions from the crew coming down, and it's so great to see their joy and our joy, our love for the moon, come through.
Yes, we are in for a real treat today if it's been anything like their observations the past couple of days. So how are the lunar science teams using this test flight to prepare for future missions to the moon?
Yeah, absolutely. This is the way that we are building our foundation for the future, from everything from, how do you train a crew to be a geologist, right? And so, working through that, getting them classroom training, field training, building the science team, building these physical rooms that we are in, designing the software that the teams are using, and then, figuring out what happens to that data. They're going to take this data and it's going to come down, and how do we get it out to not only our team, but out to the world and the rest of the science community.
Yeah, that's a great point, because when you hear these crew members talk, you would never know that they're not geologists. Your team has trained them so well.
They have been very good students.
Who can blame them? It's a pretty great topic. One more question for you. How does the science that we're doing on Artemis help support long-term exploration and including our sustained presence on the moon?
Yeah, you know what? We have a saying in the Science Mission Directorate that science enables exploration and exploration enables science, right? So you need the scientists because we are the ones who are the experts in, landing site and doing analysis of landing site and making sure we can find a good place to land, to understanding the properties of the soil so we can, design our systems to manage that, understanding the radiation environment, keeping our astronauts safe, all of these things, right? But, in return, you provide us with opportunities where now we're going to be able to collect this data and collect samples and deploy our instruments and all of that. So it's a symbiotic relationship.
That makes perfect sense. Well, Dr. Sarah Noble, Artemis Lunar Science Lead, thank you so much for joining us here today. Best of luck to you and your team, and I hope that you get to enjoy today too.
Thank you so much.
We are now Getting closer and closer to our lunar neighbor, this live view coming from the Orion spacecraft and a camera mounted on one of its solar array wings.
Houston, integrity for camera serial numbers.
Ready to copy.
Hey Jenny, these are card numbers for the various positions. For the long lens on the D5, we will have individual cards. Victor's 1008, Jeremy 1019, Reed 1012, myself 1015. For the Z9, we will have one card that is dedicated for today, serial number 1007. For the cabin camera D5, we will have one dedicated card for today, serial number 1022.
All right, Christina, we copy all. Thank you.
We just realized that we have Earth out window 1 and Moon out window 2, and Earth out window 4 and Moon out window 3, and it gives you the best idea of scale we have had yet. The Moon is about 3 to 4 times the size of the Earth, and it is almost full, and the Earth is just a small crescent out there. It's magnificent. I got a picture of it with the wide lens. Such a majestic view out here.
Amaze, amaze, amaze. Thank you, Reed.
Those are some of the communications we're excited most about today. Commander Reed Wiseman calling down their view right now. Obviously a little bit different than what we can see from this solar array camera. They are looking through the windows of the Orion spacecraft, able to see at the same time Earth and the Moon. You also heard NASA astronaut Christina Cook calling down some of the cameras that they will be using today. The crew is in that cabin configuration portion, and we expect the lunar flyby observation period to start in just about 20 minutes. Checking in on Orion's distance and speed, they are currently traveling 1,071 miles per hour, 249,159 miles away from Earth, 11,293 miles away from the moon, and continuing to grow closer. At closest approach to the moon today, the spacecraft will be just about 4,070 miles away from the lunar surface. This will be during our loss of signal with the crew as they travel behind the moon, and we will await their return to get the official number for you for how close they come to our lunar neighbor. Inside the cabin today, the lunar targeting package is the primary tool guiding the crew observations and consists of two key components. The Lunar Geography Review helped the astronauts study major lunar features in advance and help learn how to orient themselves during the flyby. Because, of course, the moon is not actually labeled like it appears here when we look at this map. The lunar targeting plan provides a detailed timeline of observation targets, background science context, and specific instructions for the pictures the crew should take, as well as the verbal descriptions that will be helpful to the science team reviewing them later. This is a screenshot from their lunar targeting package, and a screenshot specifically of that lunar.
Integrity for attitude.
Go ahead.
Hey, Jenny. Understanding we are in final attitude now for the lunar flyby, would it be possible to pitch the vehicle down 5 degrees? That would allow us to get the D5 long lens flush and have the least amount of window distortion.
We're checking.
That call from Christina Cook, NASA astronaut and mission specialist on Artemis II.
Copy.
The Orion spacecraft is positioned in a specific attitude to allow the crew to best see the moon outside of their windows today for this imaging opportunity. That call was a request for a potential attitude shift just slightly, another 5 degrees, to give them a better view and to give them a better opportunity to use their long lens camera. They'll also be using that lunar targeting package we were discussing. I am following along with that real time, so I'll be able to share with you exactly what targets the crew is looking at and when. They also trained with a lunar science passport. It's a little reference guide used on Earth to reinforce recognition of key lunar features. It is not on the flight, but it was a significant study tool for the crew to get them ready for launch. The apparent size of the moon will change throughout the flyby, and it'll appear roughly like a basketball held at arm's length at the crew's closest approach. That reinforces the need for careful planning and practiced observation techniques.
Houston, integrity for timeline.
Go ahead.
Hey, Jenny, just to make absolutely sure that we start observations when expected, we are showing in Optimus that observation time starts in about 15 minutes, and in LTP that our first target, discussion 1, starts in about 29 minutes. Can you confirm you'd like us to start discussion 1 in 29 minutes at 1900 GMT?
Christina, we are tracking that discussion 1 should start at 18:45. That's 15 minutes from now.
Okay, copy all. It may be a granularity issue with LTP, but understand that we start that observation in 15 minutes, and I bet when we get there, the green line in LTP will match the start of the white band for discussion 1. I think it's just a matter of the labeling and the granularity. Thanks for confirming.
Copy, and we'll look into that a little bit more on our side as well. Christina, can you verify for us that your green line is moving on the timeline page of your LTP?
Affirm. Jenny, I do think we're good. Looking closer, I see the labels are just not aligned with start or end times of the white visible bands. It fully makes sense now, so I think we are all set. We'll look forward to starting some observations in about 13 minutes.
Copy. Thanks, Christina.
As you heard discussed, we are expecting the crew's observation time period to start in about 10 minutes. First, they'll be conducting a warm-up, warming up to their science observations of the moon. They'll be discussing with each other, helping each other orient using the major landmarks that they've studied, asking what is familiar.
If we roll left, port 5 degrees, that would get the moon closer to the left side of window 2.
Copy, Victor. We'd like to know if it's pitch and roll or one or the other.
Jenny, we actually thought you already put the pitch in. Had the pitch been put in already?
No, we need a little while longer to talk about it.
So, Jenny, I guess what's happening is just as our orbit's changing, where it is in the window is changing, so maybe these fancy little adjustments aren't worth it. It's going to continue to move in the window. Or is the spacecraft going to keep the moon at the same point of the window if we adjust the attitude? I assume the previous.
Right now, we are pointing the center of the window to the center of the moon with 2 degrees of deadband.
The conversation you hear happening now between the astronauts aboard Orion and Artemis Mission Control here at Johnson Space Center in Houston, Texas. They are in the center of your screen, seated at the CAPCOM, or Capsule Communicator Console. That's Jenny Gibbons, Canadian Space Agency astronaut, and Artemis II backup. She was also the lead Capcom for Expedition 63 aboard the International Space Station. The crew is requesting some attitude changes to the spacecraft to allow them to better image the moon, our priority for today. Of course, those have to be discussed on the ground before they are put into work aboard the spacecraft, so the team is taking some time to do so. You also heard Gibbons reference that we are in 2 deadbands. Deadbands are essentially keeping us in the lane in which we're traveling. If you're familiar with lane assist in your car, very similar in this case. We are now 10,870 miles away from the moon, traveling 1,066 miles per hour and 249,390 miles away from Earth. Again, we recently surpassed the Apollo 13 distance record of farthest humans have ever traveled. And upon calling down some words during that milestone, Canadian Space Agency astronaut Jeremy Hansen noting that he hopes that this record that they are setting today is soon broken by future explorers. This is Artemis Mission Control. We are standing by for the beginning of lunar flyby. Expecting that to start in just a few minutes when the crew will begin a warm-up discussion, preparing for the day. They will be capturing images along while discussing what they find familiar about the moon and what looks unexpected to them. Again, just minutes away from the official start of lunar flyby, or when it is timelined for the crew. We are currently 10,726 miles away from the moon. This view on the left side of your screen coming from the camera on one of Orion's solar arrays. Other conversation points while the crew are getting ready for their flyby today. They'll be looking to orient themselves using major landmarks and annotating their observations along with their discussion. They'll have 10 minutes for that warm-up discussion.
Houston integrity. We have two folks at the window deep in discussion talking about all of the awesome features that they're seeing. We just had a huge moment realizing that Hertzsprung is about the same size as our incredible Oriental. We're really excited about this target that's kind of new to us. We're orienting on things like how we talk about albedo, finding some of the prevalent things that we're used to from all of our training, and just overall taking in this view. We also are noticing that the moon is still getting noticeably bigger as we go, even when you're watching it continuously. It's great to see these two guys get warmed up.
We love the report, Christina. Thanks. And you nailed it on why we added Hertzsprung. As you'll see in the prompts, we're looking for comparisons to the comparatively much older Hertzsprung compared to the younger Oriental. Great words.
This is Artemis Mission Control. That was the voice of Dr. Kelsey Young speaking with the astronauts aboard Orion as they begin their observation period and lunar flyby. NASA astronaut Christina Cook reporting their view of Hertzsprung Basin. The team here is looking for centered images of the basin at a full zoom, and they're hoping that the astronauts can image and describe the inner and outer rings. This is considered a degraded basin with a floor, rings, and ejecta compared to a younger Oriental basin. We spoke earlier with Julian Gross, the Artemis curation lead, about some of the terms we will hear the crew use today. One of those just called out, that's albedo, looking at surface brightness, or the amount of light a surface reflects. A few more terms that we hope to hear today during the crew's sit-reps or situation reports include embaying. This refers to one feature that surrounds another. That usually is a higher relief feature.
Houston Integrity, one report from the crew at the windows. We can actually see the moon and Earth at the same time right now. It's interesting because the Earth looks way brighter, so the Earth itself seems to have a much higher albedo than the moon. We think this is independent of our eyes focusing because, of course, the Earth is much smaller than the moon in our view, so you could think that your eyes focus for the darker sky, and that it means that it only has apparent brightness more than the moon, but since we're seeing both in the same view, we do think that this can be inferred as the Earth as a whole has a higher albedo.
Great observation, Christina, and reminder that as you're starting to look for those subtle color and albedo variations on the moon, the relatively bright albedo Earth might make those a little bit difficult, but as your eyes continue to adjust, we expect you to start to see more nuance on the moon. Thanks.
Great call. Thanks for the reminder.
We're all going to be experts in lunar terminology by the end of the day. Another one we expect to hear is mare. These are dark regions paved or filled by volcanic deposits. You also can hear them called seas, oceans, lakes, or marshes, or other bodies of water. Again, we are live in Artemis Mission Control, but on the right side of your screen, that is the Science Evaluation Room, team members who have been preparing for this day for years. The crew has significantly darkened the cabin of Orion. This allows them better views outside the windows and fewer reflections from inside. They reported being able to see the moon and the Earth out the same window at this time. We are really hopeful to get those photos. Right now, this view on the left side of your screen coming from a camera mounted on one of the solar array wings on Orion outside the spacecraft. The crew is equipped with 80 to 400 millimeter zoom lenses. The team continues their warm-up discussion. I should say the crew members aboard Orion continue their warm-up discussion. However, they are about to be prompted to move on to discussion number 2, which is near side and far side. Some of the things that they are looking to capture, the ground has prompted them to photograph anything that stands out to them and to compare the near side versus the far side mare in color, albedo, topography, and texture. They also want the crew to compare the appearance of rayed craters in the near side mare versus in the far side highlands. Of course, a reminder that some of the items that the crew, or some of the landmarks the crew are seeing today, is the first time that humans have ever laid eyes on those portions of the moon. In the targeting package, there are a few reminders of the crew. For the crew, there are time-sensitive observation reminders and science sit-rep reminders.
Integrity. We have sit-rep. The targets that are being discussed right now, it's the far side, near side comparison, and hearing some great discussion of browns and greens in the Aristarchus Plateau and how those disappear as you go toward the North Pole, and then over to the far side, you lose the color. You've got Jeremy in window 2, Reed in window 1, having a great discussion. Christina's under window, I'm sorry, Reed is in window 3. Christina's under window 1, documenting the discussion. And we've got the lights completely off in the cabin. There are some LEDs that we cannot put out that do provide some light scatter. But we have all of the internal lights off. And are letting our eyes adjust as best we can. The window 4 view, you only get about a third of the moon. Tycho is going to go over the horizon soon, and you can see Aristarchus, and then you start to lose the view as you go to the west in Oceanus and Procellarum. So far, the team is on the plan, and the long lens is being put to good use, and recordings are being made, and internal documentation of the configuration and the observations is ongoing. Science, do you have any questions for us at this time?
Integrity Science. Victor, very glad that you provided the first formal science sit-rep, as these were indeed your idea. One follow-up question, any relationship between those browns and greens you described? Do you see them blending into one another, and do you see any topography associated with either color?
I don't want to bother the window team. I just heard that, overheard that, and so I'm sorry I don't have that detail yet. I will eavesdrop and see if I can pick that up. I will try to answer that at some point. I also heard a comparison of the albedo in Aristarchus, that crater, the very high albedo spot. You can see it on the near side. There is a feature called, I believe, Burgess Alpha, that is equally or maybe higher albedo. I apologize for the gaps. I'm trying to listen and talk at the same time, but I will try to get some more information to correlate those colors from Aristarchus for you.
Understood, Victor, and good call to not bug the window team. Really like the brightness comparisons to Burgess A. Really helpful for the science team. Keep them coming. Thanks.
I also heard a discussion about the albedo of Grimaldi being a 10, and how many of us, when we were a little further away, saw that as the darkest albedo, and that the bigger Mare off to the west, sorry, to the east was still dark, but maybe a 7-8. We still think that, but you are seeing color variation, albedo variation inside of Grimaldi as well, and that even on the west side there's still a very dark part of it. But it is still the darkest. It is just not as uniform as it looked when we were farther away. We're starting to differentiate the striations of albedo inside of Grimaldi.
Copy all, Victor, and you read our mind. Superlatives like darkest, biggest are really, really helpful for us, so keep those coming.
As we were just mentioning, the crew is slated to perform these science sit reps. They are prompted to do so by an icon in their lunar targeting plan. That one coming down from NASA astronaut and pilot of Artemis II, Victor Glover. As we discussed, the Capcom is usually the only person in the room speaking with the crew, the capsule communicator. However, today, the science officer, Dr. Kelsey Young, she is the Artemis Science Flight Operations Lead, is speaking with the crew during the flyby to ask any questions that the team may have. To her right is Trevor Graff. He is one of 3 science officers. Those would be Kelsey Young, Trevor Graff, and Angela Garcia, who will also join us later for an interview.
And Houston Integrity Science Integrity was able to get a view out of window 1, which is a beautiful view. I can see the entire moon that they're looking at. We left the T-shirt up there, so I was kind of peeking through the opening in the makeshift shroud there. And once I was able to get 2 eyes on it, what jumped out at me was Vavilov. It's just peeking out of the Terminator. It's clear of the Terminator now, but it just really jumps out because it's still got the low light the low sun angle. And so where the, Vavilov has that impact over the top of another crater, where the two craters intersect on the eastern edge. So on the side closest to Orion, where the two crater rings intersect, the shadow there is the highest peak in the interior of Vavilov, and so you can see that terrain is, there's some real variation in the terrain there, that there's a nice peak where those peaks intersect, where those rings intersect, and we'll get a picture of that.
Love the description, Victor, especially the comparison and relationships you just described about topography. And if it's easier for your observations, do feel free to remove the T-shirt shroud from window 1.
Yeah, absolutely, we will do. Thank you.
Those calls coming from NASA astronaut Victor Glover. As we discussed, the crew is working in pairs at the windows. Right now, taking photos are Commander Reed Wiseman and Mission Specialist Jeremy Hansen. Serving as their support team are pilot Victor Glover and Mission Specialist Christina Cook. You're hearing those calls from Victor Glover as he is on that support team, and he is tasked with providing the science sit reps, while the two crew photographing and making annotations of the moon are in windows 2 and 3. Windows 1 and 4 are available for the support crew to fly up to, obviously look at the moon themselves, and provide these science situational reports. The view on your screen is part of the lunar targeting package, and it's something that the crew can reference as they are flying by, but this is an animation. You also heard Glover mention Orion. Orion is a major feature that the team is interested in today, and it's known as the Grand Canyon of the Moon. Until this mission, the Orion Basin had never been seen in sunlight by human eyes. Orion Basin and its surrounding ejecta could fit within a straight line distance from NASA's Johnson Space Center, where we are at today, to Kennedy Space Center. This a live view in Artemis Mission Control in Houston, Texas, where the teams are monitoring all systems, not just for today's flyby, but on the spacecraft themselves. Again, this is a test flight, our very first flight of humans on the Orion spacecraft. This team has been This team has been monitoring the entire time of the mission, as well as we have been live the entirety of the mission, and we will be continuing to do so all the way through splashdown and crew recovery from the Pacific. This is a visualization from ARROW, the Artemis Real-Time Orbit website that you can also access at any time by visiting nasa.gov/trackartemis, showing us that we are now under 10,000 miles from the moon, 9,948 to be specific, and continuing to count down. Again, our closest approach to the moon today should come about 6:02 p.m. Central, 7:02 p.m. Eastern. However, we will be out of contact with the crew at this time as they begin transiting behind the moon. At that time of closest approach, the distance from Orion to the lunar surface will be about 4,070 miles. Of course, these are estimates at this time, and we'll be sure to provide you with the official numbers once that closest approach has been reached. This shot live inside the Orion spacecraft, where our 4 crew members are continuing with their lunar flyby activities. They have just begun those activities really about 20 minutes ago, so we've got several hours of moon view opportunities. This is still a live view inside that capsule. However, you can see just how dark they have turned down the lights. Actually, they've turned them all the way off. There are a few LEDs that they cannot power off, but turning down these lights gives them better views outside of the spacecraft's windows while they photograph the moon. This also prevents any reflections from inside the spacecraft bouncing up on the windows and interfering with their photography. As we were previously discussing, the crew members are serving on teams, the first team being Commander Reed Wiseman and Mission Specialist Jeremy Hansen at the windows photographing what they see. We heard reports earlier that they could see both the moon and the Earth in the same view, and we are looking forward to seeing the moon and the Earth in the same view as well. That Earth set coming up in just a few hours. While Wiseman and Hansen are at the windows photographing, Glover and Cook are serving as support crew. They are able to assist with cameras. They are also providing those situation reports, letting us know how the team is working inside the spacecraft, what they're seeing, and how they're feeling about it. Those first blocks of teams will last about an hour, and the crew members are approaching the halfway point into their first observation block. A reminder, we have 5 of those blocks today. So they're approaching this halfway point, during which the crew at the window will switch roles. One will begin taking pictures, and the other will be making annotations on their PCD, that's portable computing device. Both of those crew members at the windows are recording audio of what they see. They are putting on headsets and recording audio into their portable computing devices. Obviously, we are not hearing this right now. This is going to be sent down to the science team, and they will be able to analyze that at a later time. What we are hearing, though, and will continue to hear, are those science sit reps a few times every block. Once this block is complete, about 40 minutes from now, we will have the teams switch. That means pilot Victor Glover and...
Science integrity, looking out of window 1. I think I may have misreported earlier saying that it was Tycho going over the horizon. That was Copernicus I was referring to. Apologies. It was Copernicus is what is farthest bounding to the east, and that is now like on the horizon or just past it. And Korolev is now a few degrees from going over the horizon. And then, next it'll be Aristarchus Plateau. And so on the west, we are getting a much better view of the Terminator. Looks like we have about 80% illumination of the moon. And Vavilov and 1 Vavilov diameter to the west is where the Terminator is right now. And so other features are starting to peek out there. The center of the illuminated part of the moon is, to the lower part is Oriental. And just around Oriental, a lot of light structure is starting to show up. A lot of high albedo, similar to the feature, I cannot remember, Burgess Alpha and Aristarchus type high albedo in the ring. So when you look at the interior ring and the external ring, it's almost as if the edges are starting to dry up and turn white. If it was something that was wet and got dry, the edges would be the part to dry first. You just kind of outline all the topography in the interior of that wall is like it was dusted with chalk or is starting to dry, or maybe dusted with snow. If this was the Earth, I would say there was snow dumped on some of the ridges on the interior of the rings of Oriental. Also, an interesting part of the discussion that I heard between Reed and Jeremy is that from Glushko to Grimaldi, there are two dark features there that look like commas, but in the wrong direction. But there's also a lot of interestingness, just a lot of geometry and squiggles and dots and lines that are starting to stand out as more small features come into view. And there also is a lot of variation in albedo. In some of those, the two dark features, for example, have on the southern edge of the larger one, the one that's further to the south, there's a very dark, the one albedo, like the southern and western part of Grimaldi. And the one to the north, closer to Glushko, is also that same dark albedo. And then around them there are some very high albedo spots just to the north of the southern one, and just to the west of the smaller one to the north. Very high albedo, almost approaching the 10, a 9 or a 10, like Aristarchus. And lots of little bright spots are just starting to pop up in this view. To the north, as you look up at the North Pole, there is a very distinct crater with a lot of very defined central peak that is also 3 in albedo, and all of that area past it, going to the horizon, gets lighter and lighter, and is very, very high albedo. And I will go look and find the name of that feature if I can look that up. And then to the south, really getting some interesting geography and topography in the South Pole Aitken Basin. And the view of the South Pole is quite amazing. We've got some Terminator there, as well as the limb view, and there is a very distinct crater right at the South Pole. And I'm going to go look up, I don't believe that is Aiken, but I'm going to go look up the name of that one because it's also giving a lot of good topography due to the shadows that I'm seeing. But that's, I was trying to bound the view that I'm seeing for you, and I got distracted by all of these interesting albedo variations that are popping up in the interior. But that's the view that we see just a Vavilov diameter to the west beyond is where the Terminator is. Just beyond, I think Copernicus is the easternmost feature that we can see. A very nice ringed, very nice structure crater to the north with a great high albedo central uplift to the north, and the south is dotted by a very characteristic crater with a lot of terrain, shadow features, and I will go try to find some landmarks to put names with those. Any questions for the observation team?
Integrity Science, love the descriptions. You're definitely looking odd up there. Appreciate seeing the training being implemented. Especially interested in your descriptions of the dark patches. You compared the comma-looking features to the albedo you see in Grimaldi and noticed that you're starting to see those color differences popping out. Any observations you want to make, especially when you get on, the PCD in a little bit, would really help us tease out the differences in those dark Mare deposits. Great description, Victor. Keep them coming.
Absolutely will do, and I know you've got descriptions on both of the window observers right now as well. Keep them coming.
Great evidence of how well trained this crew is by the science team. NASA astronaut and pilot of the Artemis II mission, Victor Glover, calling down a situation report, noting several different features on the moon and such descriptions, even saying that it looks like snow on some of the peaks. Obviously, we do not expect that to be snow, but referencing that as some of the lighting on how it looks to the Artemis II crew from their current position. The team is slated to be switching their positions at the windows now. Both Reed Wiseman and Jeremy Hansen have been at windows 2 and 3, one taking photos, one making observations and annotations on their portable computing device. At this time, we also anticipate that they are looking at a crater duo. One of those is Glushko, and the other is Ohm. The team is looking to know the extent of Glushko's ray system and how its rays differ in the Mare versus the Highlands. They also want the team to compare the ray systems of Glushko to Ohm. Ohm is considered a young crater. And if you've ever seen a photo of the Richat structure, it's also known as the Eye of the Sahara. It's 40 kilometers in diameter, and that could fit within Ohm's interior. The team is specifically interested in descriptions of that ray visibility, including the color, albedo. Remember, albedo is the brightness or the surface reflection, and the reach. Again, I am using the same lunar targeting package that the crew is referencing on board right now. This helps keep them on time as well as prompt them for when they need to make a call down to the science team and report what they're saying. It also gives them reminders of when they need to swap positions at the windows. Additionally, I'm using the Artemis II Lunar Science Passport developed by Amber Turner and the Artemis II Lunar Science team. Now, this passport did not fly with the crew, but they used it extensively as a study guide here on Earth. So a lot of the descriptions and comparisons you hear today are developed directly by the science team. We are now 4 days, 20 hours, and 43 minutes.
Science, integrity, that crater to the north, that is, it's like we've got one in the north that looks like just a textbook crater, and one on the South Pole as well. The one on the north, I think, is Pythagoras. And what I wanted to highlight about that is it is either a very distinct central uplift or just a very defined area of high albedo. If a majority of the crater, especially the floor of the crater, is, say, an albedo of 5, this center, and only a tenth of the diameter of Pythagoras is an albedo of 2, maybe 3, but it is very bright and it stands out. And then between that crater and the actual, what is the horizon from here, there seems to be another crater right on the horizon, and right on the edge of that is another patch of that albedo. It seems to be between the two craters. It's hard to tell from this grazing angle, but there is another spot just further north beyond Pythagoras. Between the two, I can draw a picture of this one and show you where that very high albedo, again, another 2 albedo surrounded by 5 and most of the area bounding it.
Integrity science, thanks for that. We agree with the Pythagoras assessment. And as a follow-up to your previous report, the SIR had questions about topography comparisons between the North Pole and the South Pole of the Moon, if you're willing to provide words on that.
Topography comparisons, absolutely. And if you have any idea what, if you draw a line between Pythagoras and the western edge of the outer defined ring of Orion, it intersects a beautiful textbook crater on the south. I would love to know the name of that. The topography differences, now the South Pole has a little bit of a benefit that it has more of the terminator, and I can see a little more shadowing there, but there's a nice crater right at the South Pole, so that's the main thing defining the topography there. Seems to be quite a bit of elevation change. I can see some very jagged shadows, a 90-degree just to the west of that crater at the South Pole. I can see a very distinct change in the shadow directions, indicating, I don't know, a very high wall or a very deep canyon just to the west of that. And in the north, it seems to be that from sort of the edge of the mare that's dark, which is maybe 1 Pythagoras diameter south, if you draw a ring about that, maybe the top 7 degrees of the moon, and just draw a ring around that, the near side is an albedo of 5 and looks quite smooth from here. And then along the same edge of the mare, the edge of the mare that kind of Grimaldi's just outside of, Glushko is just outside of, Carroll Crater is just outside of, and you start to see the stark differences between the darker 7/8 and the 5s and 6s, the 4s and 5s. If you follow that line up to the north, that line is also where the change in topography happens at the North Pole. The line defining the light and dark on the edge of the mare that you can see from Earth. Draw that line, roughly the midpoint of all that, straight to the North Pole. And on the side facing the Earth, you see smoother topography and dotted by Pythagoras and its next door neighbor crater. And then on the far side, you see a lot more cratering and a lot more topography. And again, the far side has the benefit of a little terminator there, but I am seeing a variation in the topography. It seems to be more jagged and a more challenging place to find a place to land and to even traverse in the south. All around the South Pole, and at the North Pole, it seems to be it would be more challenging to translate on the far side of the North Pole compared to the near side of the North Pole around Pythagoras.
Copy all, Victor. You really help paint a contextual picture of what you're looking at. We really appreciate the way that you're guiding us into the areas you're seeing by drawing comparisons between recognizable features. Thanks for that.
And Kelsey, another little science sit-rep moment, something I just heard from the window team is the more I look at the moon, the browner and browner it looks. I thought that was an interesting observation. The 2 observers have been on timeline, no hardware issues. They did start to talk a little bit about another feature that you'll hear more about on the recordings that they call the handprint. That was at the end of their Glushko and before they moved into their current target. They thought that was worth chatting a little bit more about. And they're preparing to switch after this.
Houston copies and concurs.
Hey, Houston and Science Integrity, another just observation from the human. My eyes have shifted a little bit since I've been up here. I've been wearing my reading glasses to look at the PCD. Well, this is a very taxing event on the eyes, looking out the window and seeing the very bright moon, then coming back inside to the dark cabin and trying to work cameras and microphones and logistics and lunch and those kinds of things, and then looking at the PCD, which is dimly lit, it's just been an exercise. It is a difficult thing to manage it. I'm up and down on the glasses, and then having to wait as my eyes adjust when I come back in. As soon as I look back into the cabin from looking out the window, I can feel my eyes adjusting, and I just have to work through it as they adjust.
Appreciate that report, Victor, and know that we are prepared to read you up targets from the ground if that would give you the ability to keep your eyes focused on the moon and not having to swap between that and the PCD. Just let us know.
Yeah, we appreciate that, science, and we will also do that for the window teams, and we'll back each other up that way as well. But we appreciate that. We may take you up on that. Thanks.
Continued detailed descriptions from the Artemis II crew aboard Orion. Again, this is a test flight, the first time we've flown humans aboard this spacecraft. So every detail, even that it's difficult to look outside the window and then back at the PCD, that portable computing device, every single detail is appreciated as we prepare for future missions. Glover also mentioned that he is now wearing his glasses now that he's in space and that his eyes have shifted a bit. This is something that happens when our astronauts go to space. There is a fluid shift from the lower half of your body up into your head, and that can cause changes in your eyes. It's something that we have seen over time for some crew members, especially now that we have been living and working on the International Space Station for over 25 years. Again, it's clear that these Artemis II astronauts have undergone extensive lunar science training, including classroom instruction, field work, and high-fidelity simulations. Training expeditions even took place in analog environments like the Icelandic Highlands and the Kemasassen impact crater in Labrador, where crews practiced identifying and describing geologic features under varying conditions. Additionally, here at Johnson Space Center, Orion mock-ups were used to rehearse crew choreography, including three-dimensional space management with an inflatable moon globe to simulate the flyby. And while on Earth, the crew also used that small lunar passport that I mentioned with descriptions, photos, and prompts to help them study the features we hope they'll see. Now, this is a view from their lunar targeting package at this time, helping them determine what they're seeing on the moon, as well as on the left, keep up with what their next target will be. As you can see, we have got a long list and an exciting day ahead of us. It's now been 4 days, 20 hours, and 53 minutes since Orion launched atop the Space Launch System rocket from Kennedy Space Center in Florida with our 4 crew members aboard. NASA astronauts Reid Wiseman, Victor Glover, and Christina Cook, and Canadian Space Agency astronaut Jeremy Hansen. The Artemis II crew passed a major milestone today when they passed the Apollo 13 distance record at 12:57 p.m. Central, 1:57 p.m. Eastern. That Apollo 13 distance record was 248,655 statute miles from Earth.
And Houston, another observation, whole moon. When you look at the moon, something I've never seen in photographs before but is very apparent, all the really bright new craters. Some of them are super tiny. Most of them are pretty small. There's a couple that really stand out, obviously. And what it really looks like is like a lampshade with tiny pinprick holes and the light shining through. They are so bright compared to the rest of the moon.
We copy, Christina. Thank you. Looks like you guys might be doing it, but remind you to swap positions at the window and take your SD cards with you. We're loving everything that you're calling down, so keep it up.
Again, Orion previously surpassed that the Apollo 13 greatest distance from Earth by humans. That was 248,655 statute miles from Earth, and Orion now 250,294 miles away from our home planet. The spacecraft is 9,033 miles away from the moon and growing ever closer. At its closest approach, it'll be about 4,070 miles away, and we will make sure we confirm what that distance ends up being. This is an approximation and an estimate ahead of that moment. We're anticipating them to make that closest approach at 6:02 p.m. Central, 7:02 Eastern, when they are in a loss of signal, transiting behind the moon. They will be the first humans in over 50 years to fly behind the moon and lose contact with Earth. We will regain that contact about 40 minutes later as they reconnect to the Deep Space Network, emerging from behind the moon, and we will look forward to seeing an Earthrise. Again, the crew is currently in their position swap portion on their timeline. This allows crew members the opportunity and the experience of all roles necessary during today's flyby. Right now, those two crew members at the window have swap positions. Again, the crew at the windows swapping positions. Right now, that crew is Commander Reed Wiseman and Mission Specialist Jeremy Hansen, while Victor Glover and Christina Cook serve as their support flyby crew members. That's why you are hearing Victor and Christina during those science situation reports. Those voices will change in about 30 minutes when they take a turn, taking photos and making annotations while at the window.
Houston, integrity. I wanted to provide an observation or a little bit of descriptive nature on something that we saw on the first day we had good moon views. This was when we saw more of the near side, and the ground helped me out with identifying Mare Imbrium. Mare Imbrium, when you have the western limb also in view, looks completely different than the normal view we have of the near side. It is the most striking feature of the western limb view that we had. And the mountain chains that form its eastern side are very prominent, but they actually stand out more than I'm used to seeing even on the western side, and the whole thing just feels like a big bump. It actually looks like a large healing wound with a high albedo forming the mountain chain around the impact basin. And I just don't think I had enough chance to describe how striking it was on that western limb view as we were coming in a couple days ago.
Christina, science, absolutely love that, especially since that's a feature that all of us here on Earth can observe from home. So I'm sure tonight everyone's going to be going out and looking for evidence of that beautiful topography you just said. Thanks for those words.
The view on your screen coming from Orion, a camera mounted on the spacecraft's solar array wing. Toward the right of your screen, the near side is the hemisphere we see from Earth. That is identifiable by those dark splotches, which are ancient lava flows.
Science integrity. A question and a comment. Question is it possible that we're seeing a Schrodinger basin from this vantage point in the Terminator at the South Pole? And the comment is Ohm. The rays coming out of Ohm are less distinct. We are not seeing the bright rays coming out of it, but the sort of 9 o'clock wedge that is formed by the change in albedo from the interior portion that is to the northeast to the surrounding lighter mare that's 270 degrees to the west. That 90 is very distinct and interior. You got some great descriptions from the two at the window about the colors in there, but in that darker part, in that wedge, you've got some really interesting color, even though the rays, the distinct difference in the albedo almost look like rays, but it's not the rays coming out, it's the just change in that albedo.
Integrity science, that is very intriguing, those color rays coming out of Ohm rather than sort of albedo. And as answer to your question, we do not think you can see Schrodinger. It's in darkness as of now. But thanks for that Ohm description, and it sounds like the pair at the window's got great descriptions that we're definitely going to dive into tonight.
Okay. If you could help me, I would still love to know what it is. There's a very nice crater. You're going to likely have a lot of pictures of it. What would be right in the Terminator at the South Pole or close to the South Pole where it's intersecting the Terminator right now?
Yeah, Victor, we're assuming you're talking about, kind of if you're looking at the Terminator, it's basically like 70% down from the North Pole. Is that where you're looking?
Contact, yes, that is where I'm looking.
Integrity Houston, that is an enabled caution for wastewater dump required. We have hit our limit. As expected, no crew action.
Copy, no crew action.
You are.
And integrity science, we're trying to figure out what you're looking at there. Is it like right on the terminator, or is it in the eliminated portion next to the terminator?
While we wait for a response from the crew, the terminator is that difference between day and night, or brightness and darkness that you see on the moon. We see this from the International Space Station as well, looking down at Earth.
And science from integrity, excuse my space orientation adaptation. If you draw a line between Glushko through the center of Oriental, and then another line from Glushko through the southern tangent of Oriental, that line would almost perfectly intersect tangentially the crater that I'm talking about, and it is on the terminator. So yeah, I think I'm not looking at the South Pole. I was a little twisted.
That line description was really helpful. I have eyes on the SIR right now, and they are actively discussing lunar geography. We will be back with you shortly.
You're hearing a couple voices today in Mission Control Houston. One of those is Dr. Kelsey Young.
Integrity science, we believe that's Zeeman crater.
Oh, I floated away from the speaker. Say it again, please.
We believe that that is Zeeman crater.
Zeeman. Okay, and can you say the first letter? I may be pronouncing that wrong. What's the first letter of that word?
Zulu. It's Z-E-E-M-A-N.
Copy. Thank you for that. Yes, we've got a great view of that. And when I went back to the window just now, the view has completely changed. Our trajectory is taking us to a new view, and I'm looking more into Babalov. I've got a nice, great view into Babalov. I'm actually away from the window right now, so I'm going to go try to give you some bounding words on the view that we're seeing. But I've got to get back to a window in a minute.
Understood, Victor. You're defining new views of the moon in more ways than one.
Again, when you hear calls down to science or from science, that's Dr. Kelsey Young, the Artemis Science Flight Operations Lead here at a console in Mission Control. You also hear communications with the crew from Canadian Space Agency astronaut Jenny Gibbons. She is the Capcom for today. She is a backup Artemis II crew member. Those calls from pilot Victor Glover asking about a feature he was seeing, specifically a crater on the moon. Meanwhile, the team here in the science evaluation room was actively working together to determine which feature he was describing. The teams at the window have continued to move through their targets, including Ohm, Aristarchus Plateau, Reiner Gamma, and we are preparing for the cabin and window teams to swap. That's when we'll hear more from Reed Wiseman and Jeremy Hansen when they take on these support roles, while Christina Cook and Victor Glover are at the windows photographing and annotating. As we briefly mentioned, if you look towards the right side of the moon, essentially, this live view coming from a camera outside the Orion spacecraft, and if you look on the right side of the moon where you see those dark patches.
Wow, yeah, I wish I had some more time to just sit here and describe what I'm seeing, but the Terminator right now is just fantastic. It is the most rugged that I've seen it. From a lighting perspective, there are little islands. There are islands of terrain out there that are completely surrounded by darkness, which indicates some real variation in terrain. Up to the north, there is a very nice double crater. It looks like a snowman sitting there. In the 5-10 degrees below the pole in the Terminator, and then on the southern edge there's almost like a hole. Looks like a hole, and it's the diameter of Vavilov size, just blackness, and then a wall of bright, and then it goes back to the black beyond the Terminator. So there's it looks like there's just a gigantic hole right there. 1 Vavilov diameter east of the Terminator, and as you go south, the Terminator is not a nice smooth arc. It's just jagged. There's almost a 110-degree turn in the shadow as opposed to the nice smooth arc, again indicating some really interesting variations, and I'm sure we'll get some photos of that. And then one of the craters further to the south of Vavilov, maybe halfway down to the South Pole, is not only looks like just a deep hole, and then there's like 2 island rays pointing off to the west and north that indicate very high ridges and very deep canyons coming up out of that crater. So again, just some really interesting visual illusions going on with the shadows there. Like I said, there look to be islands out beyond the Terminator, because some of the things, maybe even a Vavilov diameter into the Terminator are catching sunlight on the peaks up to the north and to the south. It's very, very interesting to see.
Integrity science, oh my gosh, that was an amazing picture you just painted. I glanced over at the SIR video and I literally saw fist pumps in the air. Those types of observations are things that humans are uniquely able to contribute, and you just really brought us along with you, so thanks for that.
That's awesome, Kelsey. Did you get a sit rep updating you on a slight change in logistics for PCD use?
Christina, this is Houston. We did not, but we will take it now.
We slightly changed the PCD plan for the window observers. The 2 window observers kept their PCD. So in other words, the one at window 2 went to window 3, and the one at window 3 went to window 2 when they swapped rather than staying at the window. We'll plan on all observers keeping the same PCD for all observations.
Copy, Christina. That makes sense to us, and good plan. We are coming up here on a cabin and window team swap. Let me know when you're ready for a quick vehicle status.
As you heard, science.
Houston, go for the vehicle system update.
Howdy, Reed. We don't have much for you. We just wanted to let you know that toilet right now is no-go for use as we stick with the predetermined limit for now. All crew members, please use CCUs. Otherwise, Orion is looking very good. And you have 15 minutes in this handover time where we expect Victor and Christina to switch to the windows and you and Jeremy to be in the cabin assisting. Let us know if you have any questions.
No questions at all, and they're in the swap right now. The first thing I'll tell you, I floated up to the docking hatch window and just what I'm going to call the Marin around Oriental just looks so different out the docking hatch right now. It's quite a bit darker. It's the same darkness, if not a little darker than Grimaldi, but it's cool after just being at the 400 mil for the last half hour, looking up close. I got pictures of everything Ike was just describing on the Terminator. It really is a fascinating Terminator, and then Oriental just looks so dynamic right now. It's very three-dimensional out the docking hatch compared to what I was just looking at through the 400 mil.
We love it. We are getting a sneak preview from one of our SAW cameras at what you're looking at, and we see some of what you're describing. We cannot wait to see your photos. Thanks.
Yeah, Jenny, I wish you had some longer lenses on the solar array so you could see the whole moon, but man, it is, or the up-close moon, not the whole moon, but it is just fascinating here. It's so cool.
All right, MPO and Inco, take notes. We want a zoom lens on those saws next time. Thanks, Reed.
Affirmative.
As the crew gets ready to switch positions from the window crew going back to the support crew and the support crew flying up to the windows. This view inside the room, Capcom Jenny Gibbons speaking with the crew, Canadian Space Agency astronaut. The crew has continued to provide excellent descriptions of what they are seeing on the lunar surface. In this picture, or in this live view actually, from Orion and a camera mounted on its solar array wing, if you look at the dark portion on the right side of the screen, those are visible from Earth. That's considered the near side. Those are ancient lava flows from a time early in the moon's history when it was volcanically active. And if you look towards the left, there's that dark, large crater that appears to the left of those lava flows. That's Oriental Basin. It's about 600 miles wide, and it straddles the moon's near and far side. And this mission is the first time that humans have ever been able to see this with their eyes in the daylight. Again, you hear conversation about that Terminator. You have a great view of that as well. That's the difference between light and darkness on the moon. Victor Glover explaining that as a very jagged looking Terminator due to the peaks that they're seeing and the craters that they're seeing as they prepare to cross over the far side. You also heard science officer, the Dr. Kelsey Young, Artemis Science Flight Operations lead, sharing with Victor Glover that his responses are truly something that only human eyes can discern or provide. So we've previously discussed how having humans observing the moon on this mission is being combined with lunar robotic data to help us maximize what we know about the moon. So part of that data comes from the Lunar Reconnaissance Orbiter, or LRO. This orbiter provides the robotic foundation that makes Artemis II lunar science possible. LRO has been orbiting the moon for 17 years, which makes it the longest operated lunar orbiter in history. And it's also the only American spacecraft dedicated specifically to lunar science and exploration. Artemis II lunar observations are designed to complement data like the detailed surface images from LRO. So while LRO provides those detailed high-resolution maps of the moon's surface, the Artemis II crew adds human observations that focus on regional context and relationships between features, giving scientists a larger geologic picture. Now, this combination of robotic and human observations strengthens lunar science. LRO delivers precise and repeatable measurements over long periods of time, while the Artemis II crew contributes real-time visual descriptions and context that robotic instruments alone cannot provide. The best description I've heard while preparing for this mission is to compare the difference in looking at the moon with your own eyes on Earth and trying to take a picture with a camera. The camera truly never does it justice, and it's much easier to describe and perceive what you're seeing with your own eyes than to take a photo. These Artemis II astronauts can rapidly scan wide areas and adjust their focus in real time, as well as describe relationships between features. The crew will also observe the same regions multiple times under changing lighting conditions during the flyby and provide perspectives that would take robotic missions years to accumulate. During the Artemis II mission, LRO is also attempting to observe some of the same lunar features that the astronauts are studying. Collecting this data simultaneously highlights how different instruments and human eyes provide complementary information about the moon. This LRO data plays a direct role in preparing for future Artemis missions. Its measurements of topography, surface temperature, composition, radiation, and lighting conditions are used to assess hazards, identify safe landing sites, and locate potential resources such as water ice near the lunar South Pole. This mission, Artemis II, represents the point where years of robotic preparation are paired with human exploration for the first time in the Artemis era. So together, LRO, the Lunar Reconnaissance Orbiter, and Artemis II are demonstrating how NASA moves from mapping the moon robotically to exploring it with humans. We are laying the groundwork for future Artemis missions and sustained lunar operations. A check-in with Orion. We are now 4 days, 21 hours, and 22 minutes into the flight of Artemis II, our crew aboard the Orion spacecraft. We are now 8,153 miles away from the moon, 250,742 miles away from Earth. The spacecraft is traveling at 1,030 miles per hour.
All right, Houston, the professional science update giver is now in seat 2. That is where Victor is, and Christina is nestling into seat 1 with the long lens, and we're just getting ourselves oriented here. It's a cool view in the cabin. It's actually a cool view to be off the camera now and looking at my crewmates getting up to their observation posts and looking in. It's super fun.
Copy, I'll read. We like it.
As we heard confirmation from NASA astronaut and commander of Artemis II, Reid Wiseman, they are now switching positions of the support teams and the observation teams. So initially, Reid Wiseman and Jeremy Hansen were at windows 2 and 3 in the Orion spacecraft, taking photos and making annotations in their PCDs, portable computing devices. They were also giving audible descriptions into their PCDs, wearing headsets with microphones and providing recordings that the science team will be able to listen to later. We were hearing from NASA astronauts Christina Cook and Victor Glover as they made observations as part of the support team. Now, as these teams are swapping, we anticipate hearing more from Reid and Jeremy as they'll be on the support team, while Victor and Christina will be at the windows taking photos and making annotations.
And Jenny, for the science team, if they can mark this time, I just covered up window 4 to block out the ambient light from a very bright planet Earth. And it'll be interesting to see if in the data Victor and Christina see any differences from me and Jeremy with that window blocked. It's a lot darker in the cabin now.
Copy, Reid. We're taking note, and we'd be curious too.
We are live in the Artemis mission control room during the lunar flyby of the Artemis II crew, the first humans to fly by the moon in over 50 years. Orion launched 4 days, 21 hours, and 30 minutes ago atop the SLS rocket, Space Launch System rocket from Kennedy Space Center in Florida. Our 4 crew members inside the spacecraft are transitioning their positions. The cabin and window teams have swapped. Currently at the window, we have Victor Glover and Christina Cook, NASA astronauts, and serving as support, Reed Wiseman and Jeremy Hansen. For our crews at the window, they are using handheld Nikons with an 80 to 400 millimeter zoom lens. There are also GoPros on each of the solar arrays on Orion, and that's where this view is coming from right now. We have an interior camera of the crew as well, but they have dimmed the cabin lights. They've actually turned off the cabin lights to allow them to better see outside of the spacecraft. This also helps prevent any reflections from lights inside the spacecraft reflecting onto the windows while they are photographing the moon. We talked a little bit about the views and the cameras being used on the Orion spacecraft. And again, we do have GoPros on the tip of each solar array wing. Now, the bandwidth is a little bit limited because having a crew on board, we do have to downlink a lot more data. That includes their environmental control and life support system. We are not the only data, this view that you see, coming down from the spacecraft, and so we do rely on sharing some of that with the other flight controllers in mission control. This helps the team monitor all systems aboard the spacecraft and ensure the safety of our astronauts. We are standing by for a situation report from the crew aboard the spacecraft. They've been imaging the whole moon. There is now a new crew at the window. That would be Victor Glover and Christina Cook. And so being it's their first time since they have moved up to the window positions, they have a chance to orient themselves and describe and take pictures of any color or albedo variations across the surface. Reminder, albedo is the brightness or reflectiveness.
Integrity science for a science sit rep when you're ready.
Houston Integrity, we have no external view of the moon right now for the floating crew members, so my only science sit rep is that we have Victor in window 3 doing observations and Christina in window 2 with the long lens.
Integrity, we copy. Are the shrouds still on windows 1 and 4? And if so, would you consider trying to get a view through one of those windows?
We cannot take the shroud off of 4 because the Earth is too bright and it's impacting Ike's peripheral vision. And then I can get a grazing glimpse out the docking hatch window. I can see Oriental south down to the South Pole. And the primary thing that I see from Oriental right now is just the long trenches that come out. And, you know, when you come out the north side of Oriental, the ejecta kind of boulders across the northern half of the far side. But coming out the southern half of Oriental, I just see those large, here they look like gorges. They're almost like rain when it comes down the Grand Canyon and fingers off into the desert, kind of what it looks like. Also, Burgess Alpha is extremely bright. It's the brightest thing that I can see. Even brighter now than Aristarchus, which is heading off to the Terminator. It's almost impossible now to see Aristarchus, the thing that Jeremy and I looked so much at. I can just barely see the crater rays from Ohm, and I would say for albedo right now, I would go back to Gramati is still extremely dark, especially in that southwest corner, and there are parts of Oriental and the outer ring of Oriental that reach that same level of darkness, especially the rings of Oriental reach the same level of darkness as Gramati. And then south of Gramati, Jeremy and I were noting a few other just really dark areas of cratering, Mare there, and those have that same darker albedo, but Burgess Alpha is the brightest, and Gramati is the darkest.
Integrity Science, that was a great description. Thank you, and thanks for the docking window geometry to give us that description. Any comments before you go on the annular ring in Oriental?
The annular ring, which I think everybody kind of describes as like a pair of lips or a kiss on the far side of the moon from here, is very circular in nature. The northern part of it is wider, darker. The southern part is much lighter. It is very neat looking, and but it is far more circular than I remember it looking in our training. The darkness of the northern side of the annular ring is the same darkness from here out this docking hatch window as the center mare in Oriental. Not quite as dark as Gravati, but it is probably only because dust and lunar regolith has kind of impacted over time.
Reed, that's exactly what we were looking for. Thanks so much. You have heart hands coming out of the SIR.
Say that again, Kelsey.
Just saying that the sir was really excited about that. That annular ring was something we were really eager to hear about, so thanks.
Yep, you bet. And now Victor and Christina are moving on to Oriental. I got them situated over there a little bit late.
That was NASA astronaut Reid Wiseman, now providing a science sit rep as he is away from the windows most of the time. He is working as the support person along with Jeremy Hansen in the spacecraft, as Victor Glover and Christina Cook are now at windows 2 and 3, able to photograph the moon. Christina and Victor are also providing recorded information to their portable computing devices, that's their PCDs, and the science team will have access to that at a later time. They will then review it and compile all of this data to help further our understanding of the moon. One of the items you heard mentioned was Oriental Basin. This has been a very exciting opportunity for the crew. They have all been very excited about seeing Oriental, as well as the science team has been looking forward to it. It is known as the Grand Canyon of the Moon, as we discussed earlier. From the pictures, the science team is hoping that the crew will take centered images of the entire basin and surrounding craters in a single frame, but also use those 80 to 400 millimeter zoom lenses to create a mosaic entire basin. With their unaided eyes, the science team is hoping the crew will describe southern dark annular ring, which you heard Reid just describing, as well as any color, albedo, texture, or topography across the mare patches and ring mountains. Science team reports that the observations will be used to study the geologic evolution of the youngest lunar basin and to inform formation hypotheses for the annular ring. And again, another fun fact about Oriental is the diameter is the same distance between Johnson Space Center, where we are today, and Kennedy Space Center, where the crew launched on April 1st. This live view from the Orion spacecraft on the Artemis II mission, now 7,373 miles away from the moon, 251,130 miles from Earth. Again, the Artemis II crew passed the Apollo 13 record of the humans farthest from the Earth today at 12:57 p.m. Central Time, 1:57 p.m. Eastern Time. That distance set by Apollo 13 was 248,655 statute miles. We have clearly passed that, and we expect to pass that by about 4,105 miles. That will be when the spacecraft reaches its farthest distance from the Earth. It could be around 252,760 miles, but again, these are approximations and our targets, and we will make sure to report back the final numbers once we have them. We have some refined times of when we expect to have Earth set of Earth behind the moon while Orion flies behind the moon. That would be about 5:41 p.m. Central, 6:41 Eastern. The spacecraft would make its closest approach to the moon at 6 o'clock Central, 7 Eastern, and that would be about 4,066 miles. And then at 6:02 p.m. Central, and the spacecraft will reach its farthest distance from the Earth. We anticipate that'll be about 252,755 miles, which would be 4,111 miles farther than Apollo 13. We would see Earthrise again at 6:21 p.m. Central Time, and a few minutes later, regain communications with the crew. Currently aboard Orion, Victor Glover and Christina Cook are the two team members conducting lunar flyby observations, meaning they are using the Nikon cameras to photograph the moon, and their PCD, or the portable computing device, to conduct annotations. They are both recording information that will be downlinked to the science crew, and tomorrow morning the science team will have a conference with the team while the information is so fresh. They'll be speaking with the crew about their observations and their data collection. Otherwise, most of tomorrow, Flight Day 7, is considered an off day. We are on Flight Day 6 of the Artemis II mission, the first time in more than 50 years that humans will observe the moon directly, providing a critical opportunity to practice how lunar science will be conducted during future Artemis missions. If you're just joining us, the crew is well into their lunar flyby observations, and we anticipate that we will hear from them soon. A few times every hour, they are slated to call down with science sit reps or situation reports. We most recently had one from Commander Reed Wiseman. He and Jeremy Hansen, mission specialist, were first at the windows today to photograph and make annotations of what they were seeing. Therefore, we heard more from Victor Glover and Christina Cook earlier in the day during those first blocks. But now that Reed Wiseman and Jeremy Hansen are on the support side, they are the ones calling down what they are seeing from windows 1 and 4. Earlier, we heard that the Earth is so bright in window 4, they have had to temporarily cover it with a t-shirt. The moon preserves a near-continuous record of solar system history that has been erased on Earth because the moon doesn't have an atmosphere. So things that we experience on Earth, like weather or plate tectonics, don't really apply. So the lunar surface retains evidence of ancient impacts, volcanism, and solar activity that scientists can study today. And studying the moon helps scientists understand how planets formed and evolved, how the moon influenced our own planet Earth's history, and how the sun shaped conditions across the inner solar system. The moon also serves as a unique platform for studying the broader universe. Artemis science is designed around questions best answered by humans, working alongside robotic systems, combining decades of robotic lunar data with real-time judgment, context, and adaptability that only humans can provide. This mission, Artemis II, is serving as a proving ground for lunar science operations, which allows NASA to test how science is planned, executed, and supported during a crewed deep space mission ahead of our future Artemis flights.
Integrity, time for a window team position swap. So Victor and Christina, please switch places if you've not done so already, and remember your SD card for the camera.
We're in the swap right now. They're wrapping up their last comments, and they'll switch over and change cards from the long lens.
Copy.
As you heard in that call, it is now time for the team members at the window to swap positions. That means Victor Glover and Christina Cook will be switching roles. One of them has been photographing the moon with a Nikon with an 80 to 400 millimeter zoom lens, while the other was making annotations on their portable computing device. And both are recording audio that the science team will be able to listen to. We are now 2 hours and 10 minutes until we expect to lose signal with the spacecraft as they fly behind the moon. And the next target for the crew is considered a crew choice event. They have the option to focus on any regions or patterns or features that interest them. The science team has asked the crew to capture pictures that illustrate their choice, as well as at different zoom levels, and to describe why those certain features or regions caught their eye. Those recordings are part of what are being saved on their PCDs, portable computing device, that will be sent to the science team for analysis. The crew has been allotted 8 minutes for this crew choice event, and it's also a time for a scheduled sit rep or situation report. So we expect to hear them calling down what they are seeing soon. Something that the crew or that the science team has used to help prepare the crew is a cue card. These ask for a feature ID if they happen to know the type or name, and if it is a target. Of course, in this situation, when they have a crew choice, they do not need to, it may or may not be a target. They want to know the location and the observation style. They've also asked for the geometry of what's being captured, the size, shape, boundary, and preservation, as well as the color and shadow. So the color tone, the albedo, that reflection or brightness, and any shadows or illumination. Next, they're interested in structure and texture. That includes slopes, structures, and textures, of course, and geologic relations, like association to other features, any contact to those features, and of course, their thoughts, impressions, or interpretations. They are interested even in emotions and excitement that the crew may be having. This flyby day has been practiced in many ways, even in sims here in Mission Control Houston. The team also conducted some field work, learning how to look for specific geologic features. They also photographed a large globe, and the science team helped them determine which features they would be targeting and how to look at those. We have a few more minutes that the crew would be photographing their crew choice. Again, this is NASA astronauts Victor Glover and Christina Cook at the windows. They will then move on to another discussion portion. This is for the far side albedo, that reflectiveness, and color that they are seeing. We heard earlier about some browns seen on the moon, which is very interesting, especially here from Earth, where we are just seeing whites, grays, and maybe even black at some points. When they get into that discussion for far side albedo in a few minutes, the theme is looking to know how that color and albedo is, what those variations look like across the far side. On the right side of your screen, the Science Evaluation Room, or SIR, where team members are looking real time at what the crew is seeing. And even earlier, we're...
Houston Integrity, you ready for a science zero?
We'll take it.
Okay, the crew has swapped positions. They're in their crew choice element. I've been listening to both of them for a little bit, and they're really enjoying, they both decided to pick the Terminator, and they're spending a lot of time looking at the Terminator, just talking about the resolution that they can see, the depth of the craters, and the various interesting and unique excavations that they can see. So Victor is on the long lens, and Christina is just looking out the window, and I'm sneaking a peek in T-shirt window. It looks like, I don't have the best angle here, but it looks like Aristarchus is on the limb of the moon now. It's amazing how quickly it changes as we speed around the far side of the moon, stuff that's leaving our field of view, and now we have a lot of the dark side of the moon that, it's missing for us right now, but it would be in view if it was lit at all.
Jeremy, Science, thanks for that sit rep. Do have a question. A few times we've heard you and the other crew describe change during the course of your flyby. Would be interested in future descriptions of more verbosity about how it's changing. Thanks for the great sit rep.
Yeah, Kelsey, sounds good. We are definitely keeping an eye on that. My eyes have just not readjusted. The moon is so bright when you come back to the window. I was just in the interior of the cabin. I've come back to T-shirt window, and it's just overwhelming brightness. And my viewing angle is a bit challenging, so I won't be able to give you great observations from this window. But I will talk about something that I was talking a lot about in my recordings earlier, which was we've been talking about some shades, and so we have obviously the dark and the light gray, and then we've talked about naming some colors, a brownish hue and a greenish hue. And I'll tell you, like right now, Aristarchus, the plateau is hard for me to see from this window, but that had greenish hues to me and was very unique. I didn't see anything like that anywhere else on this side of the moon. And then I see a lot of these, what I would call brownish hue areas. There's a number of them. And they, for example, in the northwest corner of the highlands, to me it looks like the brownish hue is caused by ray or ejected material landing on the highlands, and then we obviously see the ray areas as a lighter albedo, but in between the rays where the deposit would be thinnest, that is what it looks like is causing the brown to me. So I saw that in the northwest side of Aristarchus, or sorry, that dark area of the highlands, northwest side of the highlands. I saw it in the highlands to the east of Glushko, and then I see those same brownish hues west of Oriental, and I drew a contact there on OneNote, but that's a huge region, kind of like a piece of pie with the point of the pie pointing at Oriental and then going up towards the northern side of Hertzsprung. And that is an area that just looks like that brownish albedo.
That was fantastic, Jeremy. We had heard rumors of the green and brown hues, and so you really read my mind on asking about those. Understand they likely didn't have any contact with each other the way that you described them, but please correct me if I misunderstood that. And then last thing, I'll make the same offer we made to Victor earlier. If it would be helpful for us to verbalize any targets so you can stay at the windows and keep your eyes adjusted to the moon, please let us know.
If you got something you want us to look at, Kelsey, you can send it on up.
Definitely not looking to interrupt your flow, Reed and Jeremy, only offering assistance if you guys want to keep your eyes off of the PCDs.
I see what you're saying. Okay. Not really science related, and we definitely learned this in Apollo, but the thing that is just most fascinating, I think, to me and Victor right now is even as rugged as the far side looks, when you look at Oriental and Home, it's rugged. But man, when you look at the Terminator, it is just like impossibly rugged, and it reminds you that the whole far side is that way, and just the Terminator is really bringing out the shadows and the hills and the valleys, and it is just, it's unbelievable. It's like no surface of the Terminator is not marked by meteor impact, and it's just, it is very impressive to look at that, and you realize that that is true across the whole far side. You just can't see it due to sun illumination right now.
Reed, Houston copies, and we were commenting on the same thing. Even from our view, the Terminator looks absolutely alien because there's just so much texture in there that we're just not used to seeing. So thanks for sharing that with us.
There's also, I don't know the name of it, coming out the south-southwest of Oriental, right on the southern Terminator, is just a massive crater. I don't know the name of it. Maybe you can look on the solar array wing video and tell me it's right. It's the southernmost crater you see on the Terminator right now.
We're looking for you. We're loving that picture. Thanks for showing us. And Reed, as an answer to your last question, we believe that that is Chebyshev crater. And the sir agrees with that.
Okay, that picture I was just showing you is an 8X iPhone out the docking hatch for the high grazing angle. It's just amazing.
We love it. Thank you.
This is Artemis Mission Control in Houston, Texas. Mission elapsed time, 4 days, 22 hours, 12 minutes into the flight of Orion. This is Lunar Flyby Day for the crew aboard the spacecraft. Reed Wiseman, Victor Glover, Christina Cook, and Jeremy Hansen are now the farthest people to have ever traveled from Earth. This a live view from inside the spacecraft. They have turned off the lights so they're able to see outside and photograph the moon better with no reflections from inside. And for a very brief moment there.
Integrity Science, thanks for those iPhone views. It's helpful to see what you're seeing.
We very briefly saw NASA astronaut Reed Wiseman showing a picture he took on his phone of the moon. We do expect to get all of the photos that the crew is taking today, and we cannot wait to share some of those with you. But pretty cool in the meantime, just to see one quick shot from what the crew is seeing. And this view from outside the spacecraft on Orion's solar array wing. Orion is now 6,643 miles away from the moon and continuing to grow closer. Again, their closest approach will be about 4,066 miles. The best comparison is if you held a basketball at arm's length. That's about what it would look like to the Artemis II crew at their closest approach. This view showing at the very top, a camera coming from Orion, continuing their flyby of the moon. We have 3 more flyby observation blocks after the completion of this one. Down on the bottom left of your screen, that's the SIR, the Science Evaluation Room, where team members are continuing to work through all of the targets that the crew is photographing today, and they've helped identify some of the craters and some of the other items that the crew has seen on the moon's surface. Down on the right is Artemis Mission Control here in Houston. Those 2 rooms down at the bottom are just down the hall from each other. And we are just a few minutes away from the next cabin and window team swap. That means Victor and Christina, who have been at the windows, will fly to the cabin, the background essentially, and be their support crew for Reed and Jeremy. Reed and Jeremy will move back up to the windows. The crew is continuing their discussion portion of the flyby in the lunar targeting package, where it says far side albedo/color. They are looking. The science team is looking to get a good understanding of what the crew can see on the far side at this point, and its brightness as well as any colors. We did hear earlier Canadian Space Agency astronaut Jeremy Hansen reporting that they could even see browns and even greens on the moon. I'm really looking forward to seeing those photos. And in just a couple of minutes, the teams will swap from the cabin to the window. Another rundown of just how this flyby is choreographed inside the spacecraft today. So these activities have been timelined, and there are these 5 blocks of time during which the crew is going to be observing the moon from Orion's windows. Now we are just coming up on the end of the second block, and we'll start the third soon. So at any time during those blocks, 2 members are at the windows working in a pair. One is taking photos from window 2 and has a blue shroud over the window to help prevent any reflections from inside the spacecraft. They are also using an 80 to 400 millimeter zoom lens. And the other astronaut on the window team will be in window 3 using their portable computing device to make annotations. Now, again, both of those crew members are making audio recordings of what they are seeing, and we are not hearing that right now. Those are going to be downlinked later to the science team, who will evaluate them and use that data to inform our understanding of the moon. Those 2 crew members at the windows swap roles.
Integrity Houston, it is time for another swap between the cabin and the window teams. So we have 15 minutes of handover time, and then we will expect Jeremy and Reed at the windows and Christina and Victor at the cabin. I have no new vehicle updates for you, but I do have a photo location for some photos on Ike's PCD, and I want to let you know that Jeremy's family have arrived in the viewing gallery.
Okay, Jenny, we copied most of that. The only thing we're missing is what you meant about the photo location on Victor's PCD. And hello to my family. I think that must be Catherine and Devin that are there. And I'm glad they made it into the viewing room. And we copy it's time for crew swap. The A team's coming out of the windows and the B team's going in.
Okay, copy. All I meant to pass for Victor's PCD is that there are some late load photos that were requested that are now in his favorite photos folder. And you're exactly right. We have Catherine and Devin here. They give you a big wave, and they're super excited and happy to see part of what you're seeing.
Okay, copy, Jenny. We're not sure what we're looking for in the PCD, but we're going to poke around, and we may be calling you back about that one.
All right, that's no problem, and it's unrelated to flyby.
This is Artemis Mission Control here at Johnson Space Center in Houston, Texas. And as you just heard, Capcom, or Capsule Communicator Jenny Gibbons, Canadian Space Agency astronaut and Artemis II crew backup, relaying to the teams in Orion that it is time for a swap from the cabin to the window teams. We're now at the tail end of the second lunar flyby observation block. Again, we have 5 of these today. Most recently, Victor Glover and Christina Cook were at the windows photographing and making annotations, while Reed Wiseman and Jeremy Hansen were in the cabin providing support, whether that is SD card help, but also science sit reps, calling down any situation reports for what they are seeing on the moon or anything about the vehicle status. With that call to make a swap, Reed and Jeremy will be back at the windows, making observations for what they see at the moon and taking photos. Again, you're watching live coverage of NASA's Artemis II.
But something that's really awesome up here is we now have the moon and the Earth in window 3 simultaneously, and the moon is a gibbous, and the Earth is a crescent. And I'm guessing in about 45 minutes we'll have 2 identical crescents as we change our position in the universe.
That is pretty darn cool. Thank you.
That's the Artemis II crew, the first astronauts to fly by the moon in more than 50 years, reporting that when they look out of window 3, one window, they're able to see both the Earth and the moon at the same time now. Now, obviously, our view is from a camera on the solar array wing pointed at the moon, and we hope to see that view of both the Earth and the moon soon. Some upcoming times for what you can expect. In about an hour and 40 minutes, we will have Earth set. And during that time, we will have a view of Earth going behind the moon. Shortly after, just a few minutes later, we will lose signal with the Orion spacecraft. This is tracked as it is going behind the moon and out of reach of the Deep Space Network. At 6 o'clock p.m., the spacecraft will make its closest approach to the moon at a distance of about 4,066 miles. At 6:02 Central, the spacecraft will reach its farthest distance from Earth at about 252,755 miles. Of course, these are approximate, and we will make sure to provide you with the final distances once those are confirmed. At 6:21 p.m., we will have Earthrise from the Orion spacecraft, but we will not have communications with the spacecraft until 6:25 p.m. Central, when we expect to acquire signal with them after they've emerged from behind the moon. Again, you're watching live coverage of NASA's lunar flyby for the Artemis II mission, the first crew to fly beyond the moon in over 50 years. The astronauts inside the spacecraft are switching positions, 2 at the windows and 2 serving in support roles, before they start their third timelined flyby observation for today. We've heard great calls from the crew so far describing what they're seeing, all well trained by the science team here on the ground. Another major milestone for the crew today will be to experience a solar eclipse from their capsule. No one on Earth will experience this solar eclipse. To the astronauts, this will look a lot like a total solar eclipse on Earth, except the moon will be huge compared to the sun. Whereas if you're standing on Earth and looking at a solar eclipse, the moon and the sun appear to be about the same size in the sky. As the moon begins to cover and then uncover the sun, the astronauts will see a partial solar eclipse, so that's before and after totality, and during that time frame they will have to wear eclipse glasses so they can safely view this phase. They also intend to capture images of the sun's corona during the eclipse. This is a rare glimpse at the innermost corona that will only be captured by the astronauts' cameras. During the eclipse, we also look forward to the crew members describing what they will see, which includes unique light features like the shape and size of the corona and potentially even lunar dust. At the same time, Venus, Saturn, Mars, and Mercury will be near the sun, so they may be able to identify what part of the sky they're looking at. This can help train future Artemis astronauts on what part of the sky they're seeing, which is useful knowledge in challenging situations when they may need to rely on that information instead of instruments for navigation and orientation. That eclipse window will last about an hour, and it'll happen near the end of the day today, closer to 7:35 p.m. Central, 8:35 Eastern. As you can see in this live view from Orion, the spacecraft is maneuvering around the moon, and the views of the moon have changed since we started our broadcast. The near side is now very far to the right side of your screen. This is the side that we can see from Earth. That darkened portion are ancient lava flows. The crater down towards the bottom of the moon is Orion, and this is a crater that was previously never seen before by human eyes until this mission. Everything to the left of Orion is considered the far side. and this is what we typically do not see from Earth. Just a reminder about this view. This is coming from a GoPro camera mounted on the tip of one of Orion's 4 solar arrays. Each solar array has a camera mounted on it, and the bandwidth is limited due to we have a crew on board, and this is our first flight of crew aboard the Orion spacecraft. So having a crew means we have to have an environmental control and life support system. There's a lot of data around, a lot of data to bring down for the crew members to keep us up to date on everything happening aboard the spacecraft. So we have to share our bandwidth when it comes to imagery and data. Inside the Orion spacecraft, the astronauts have completed their cabin and window team swap, meaning we have moved into the next block of lunar flyby observations. Jeremy Hansen and Reed Wiseman are now back at the windows, taking photos and making annotations. About halfway through this block, they will switch positions at the windows and will be prompted by the ground to do so.
Houston integrity for SITREP. First of all, I'll just talk about the experience that I had during Victor and my observation time. It was an incredible experience. We definitely noted how much more you can see with the zoom lens. Even though we have a great visible eye image, there's just a lot of texture that just pops right out at you when you can zoom in. So almost just using it like a telescope, the camera lens. We really enjoyed our discussion time. That was a great innovation on the lunar targeting plan. We were both able to describe a lot more kind of with flow, I would say, when we were talking to each other. And it was also, we sort of were able to bounce ideas off of each other and come to new conclusions. We had, I think, a very successful talking through of some contacts between different color areas, both in the mare and in the highlands, and we identified some really unique texture areas as well. At one point, towards the end of the images of my time in window 3, I just had an overwhelming sense of being moved by looking at the moon. It lasted just a second or two, and I actually couldn't even make it happen again. But something just drew me in suddenly to the lunar landscape, and it became real. And the truth is, the moon really is its own body in the universe. It's not just a poster in the sky that goes by. It is a real place. And when we have that perspective and we compare it to our home of the Earth, it just reminds us how much we have in common. Everything we need, the Earth provides, and that in and of itself is somewhat of a miracle, and one that you can't truly know until you've had the perspective of the other. I'll switch into some logistics stuff. The Peltors, both their batteries stopped providing the active listening, but we have verified they are still recording, and so we are able to have discussion time and hear outside our recordings by just moving the ear cup off of the ear. Other than that, everything's working well technically, and we've been able to find all our targets, and we're having a really great time.
Thanks, Christina. We copy those logistics for the Peltors, and also thanks for bringing us into the cabin with you with that description.
Right on time. NASA astronaut Christina Cook, a mission specialist for Artemis II, calling down a science sit rep, a situation report. Good news, reporting that she and her teammates have been able to capture all targets that were listed. Christina also gave a vibrant description of just how it feels to be there and to see the moon up close and not just something passing in our night sky. Currently, the team members at the window are Reed Wiseman and Jeremy Hansen. Meanwhile,
Integrity cabin team for window shroud.
We're listening. Go ahead, Jenny.
Hey, Victor, we have a temperature constraint on the windows, and the shroud might be getting us close, so we just want to check on the state of window 4's shroud, whether you believe it's still necessary because maybe things have changed with our viewing, and if so, we would like to request to have the shroud removed.
Houston, we believe it is necessary. We pulled it off just as a corner. It is very bright. It definitely would affect our night vision and maybe comfort. But is there a time? Can you tell us when we would have to take it off by?
Unfortunately, since it's been on for a while, we are going to have to request that the shroud is removed, and we can recommend something that could block the light but just create a bit of distance between the window and whatever is covering it. Something like a t-shirt would do the trick and help.
Okay, we're removing the shroud, and we will we'll make it work. Thanks.
Thank you, Victor. We know it's pretty bright in there now with that window uncovered. We will also offer that airflow on the window would be helpful. So if you want, you can also retrieve the condensation hose, which should be friction fit onto one of the diffusers. And that on the window would also help.
We can easily point a diffuser at the window, so we're going to start with that, and it's pointing at the window now.
Okay, we'll take that, Victor. Thank you. Please keep us updated.
That call from Capcom, Jenny Gibbons, CSA astronaut and Artemis II crew backup, to the crew aboard Orion, letting them know that they will need to remove the window shroud they had placed on window 4. They initially placed that shroud there to block out some of the light from the Earth. It was extremely bright coming in the cabin and interfering with some of their viewing opportunities out at the moon. This was a request from ground teams to ensure that they are protecting other systems, and the crew has been offered the opportunity to use something else to cover the window. Meanwhile, Reed Wiseman and Jeremy Hansen continue with their lunar flyby observations. They have just looked at Glushko crater. That's about when we heard that call down from Christina Cook with that description of everything she had been seeing during her her observation period and what she was seeing at that time. The science team asked this crew to take centered images of the entire crater and their ray system in one frame. They're also interested in knowing the brightness, texture, and extent of Glushko's rays and how they differ in the mare, or that sea area, versus the highlands. Glushko is considered a young lunar crater, and these observations can help understand material properties of those craters.
Science, integrity. First, I wanted to start off with connecting with what Christina said, that it was very moving to look out the window. I had the unfortunate sequence to start looking out the window and then moved to the long lens, and it was hard to speak looking through the zoom. Because I went straight where Christina went, and I was walking around down there on the surface, climbing and off-roading on that amazing terrain. I also want to underscore something that she said. As we continue to explore, when we actually do go down there to the surface, I know for safety reasons that we would never send someone alone, but I just want to really emphasize how important the discussion time was. When we started to talk, we not only got better science discussion, we got better human connection, and so doing this as a pair, we just learn and grow together, and that's just super important, so thank you for adding that to this plan. Reed just passed me a note that the Orion Tall Basin annular ring has a similar albedo to the center, but a different color. It has more brownish tones in it, and he said it's very distinct now that he's been staring at it.
Victor, thank you. You got a cheer from science there, and we all just went on that moonwalk with you, so highlighting how important it is to talk about these things. I also want to let you know that we have Deanna Glover with us in the viewing gallery. She's all smiles.
Well, you just got a bunch of cheers up here. Hey, babe. I love you from the moon.
We love that we got a hey babe too, and we also have one of your lovely daughters here watching you guys work.
Thank you guys for doing that and for supporting them through this. And to all of you, Genesis, Maya, Joya, and Corinne, I love you. And Deanna, I love you. I'm glad you get to be there.
We've had some really sweet words from the crew members aboard Orion today, as their families have been able to filter in and out of the viewing room here at Artemis Mission Control at Johnson Space Center in Houston. Victor Glover also giving a great science sit rep and just a description of how it must feel if you were down on the lunar surface while he was looking through that 80 to 400 millimeter zoom lens. He also expressed how important it was to be able to talk through that real time with Christina Cook and stressed the importance of that on future missions, that it not only made their discussions better, but also more human. Glover and Cook are in the support roles right now, not taking photos or making annotations at the windows, but they are also encouraged to have their midday meal at this time. For lunch today, those two crew members have options of beef ravioli, salmon, butternut squash, sweet and savory kale, pickled beets, cherry blueberry cobbler, tuna noodle casserole, tomatoes and artichokes, broccoli, and chocolate peanut butter bar. Once Glover and Cook return to the window portion of their flyby today, Reed Wiseman and Jeremy Hansen will get into their midday meal. Again, this is the third of 5 scheduled blocks for our lunar viewing today, and if you were watching at the start of the broadcast, you can definitely tell the difference in the distance from the moon. We are now 5,518 miles away from the lunar surface, and again, expecting the crew to get about 4,066 miles away. They are currently 252,050 miles away from Earth, and every mile is a new record, having surpassed the Apollo 13 milestone for furthest distance earlier today. If you look down to the bottom right of the moon in that darker looking area, that is Orion Basin. We have continued to lose views of the near side. It is just barely visible over towards the bottom right side of your screen. And then you'll also hear later about that terminator. That's the line between light and darkness while on the moon. It is really exposing some of those craters at this time. A couple of the other features in view right now are Hertzsprung Basin and Vavilov Crater. Hertzsprung Basin is nearer to the center of the moon, closer to that terminator line right now, and Vavilov Crater is just on the outskirts of it, closer again to the terminator. Towards the bottom of the moon and to the left of the terminator line, or currently shadowed in darkness, is Apollo Basin.
Science from integrity. Let me find out how far we are from the moon right now. But our view is about a third of the moon is in eclipse. That beautiful terminator is out there calling to me. We're 4,691 miles from the moon. And what looked like in the terminator about a third of the way up from the southernmost part of the terminator looked like a dinosaur print if one was running to the northwest. Now is clearly a crater with a bunch of craters around it. And that terminator, I can only see about half of it. I'm looking through the docking hatch window right now because we have the Z9 in window 1. But that terminator has moved. I guess I've been using Vavilov the whole time, so it's gone 2 more Vavilov craters to the west, and so a few more features are starting to peek out into the sunlight there with that low sun angle, and so you still have ridges and valleys showing up very clearly, a very jagged terminator, and a few islands of light out there with some high elevation shining in the sunlight in that darkness. And on the eastern side of the moon, let's see, Grimaldi appears to be one of the farthest east features, and that is maybe 5 degrees from being right on the limb and going off over the horizon. It is interesting, just looking at Oriental, that my first impression of it is all of the dark areas appear lighter, which I think makes sense because it is now facing, well, it's still relatively the same to the sun, but my angle to it is different. So I'm looking at it from a little more, even further to the side as we pass it. But all the darker features appear to be just a little bit lighter from this vantage point. The darker ring structure in the outer and inner ring and the interior, as well as the annular ring portion, everything seems to be just a smidge lighter at this point.
Thanks for that description, Ike. Any additional words you can provide on Oriental would be wonderful, as that is such a high priority target for us. And while I have you, as we get closer to target 15, which is the Terminator target, if you can find Zeeman Crater again that you were looking at earlier, everything to your left of Zeeman would be getting into the South Pole Aiken area to help you orient yourself.
Zeeman is a great waypoint out there. I definitely see it. Yeah, Zeeman is very easy to find, and that is awesome. Thank you for pointing that out. Feel free to do that as often as you think of things. Let's see, looking back at Oriental. Okay, another thing, after looking through the zoom camera, man, you guys are smart. You probably did this on purpose, but after looking with my plain eyes and then going to the 400 millimeter zoom, now looking at it, I see the cliff face as if you were standing in the center. That inner and outer ring have definitely some real terrain to them, and now I can see that as terrain. Now that I look at it even with my naked eye, I can tell that there's a lot of elevation and that, like I said, a cliff face on that eastern edge where all the darker deposits are. And it's just the scale now. Looking at it from far away before, it seemed like flat with color painted on it, but now that I look at it, I can definitely see that there is, different depositional characteristics, and so the darker is some other material, but there's also some shadowing going on because of the cliff face that is a part of that crater wall.
Great description, Victor. Thanks, and really interesting to hear now the distinction between shadow and color. Before I let you go back to other observations, you mentioned that Reed saw a browner hue to the annular ring than the rest of Oriental. Are you seeing that from your vantage point?
The way that I'm looking at Oriental, again, I'm still in the docking hatch window. There's like a thermocouple right here in the center of the window, and it is the orange Kapton tape color, and so it is unfortunately, it's like trying to look at stars, next to a metropolis. I think it's drowning out any color that I could pick up from the moon. I am not able to see that color, but I have not looked at it through one of the forward face, or from one of the windows 1 through 4. I think when I get away from this Kapton tape strip that I would be able to see the variation that Reed's talking about.
That is great feedback operationally. Thanks, Victor. I'll leave you to it.
Integrity with a question from the window team.
Integrity, this is Science here with you.
Yes, they have a question to help inform a theory that they're sort of tossing back and forth. What is older, the Mare seas of the near side or Oriental?
Stand by, Integrity. We're going to get you a little geologic history here. Integrity Science back with you for some lunar volcanism when you're ready.
Go ahead.
You're making our day down here getting to talk about lunar volcanoes. Oriental, as far as Mare go, is younger than almost all of the Mare on the near side. The exception are features like Aristarchus, which really pop out to you guys and really pop out to us here on Earth. That is younger, but other than that, Oriental is pretty young as far as Mare go.
And Kelsey, thanks for that. We love lunar volcanism too. How about when the actual crater was formed?
Yeah, we're going to get you an age for Oriental, and while we're getting that, Christina, can you, maybe you've heard the window team talk about the sort of contacts around Oriental, but because that material is so much younger, if anything pops out to you about physical relationship between that and surrounding terrain, we'd love to hear it.
Yeah, definitely. They are discussing a contact relationship that could explain some of the color that they're seeing in certain areas. And so it was really about the ejecta of the creation of the basin and understanding the superposition of its ejecta and Mare on the near side or other features. So thank you. We'll take the insight when you have it.